Good morning. Welcome to the second session of the Adiala Summer School on Responsible AI. And today we focus the session first in the topic of Agentic AI from the point of view of the technology, from the point of view of the platforms in the topic. And Juan Luis Suárez, Juanlu, as you know, is together with Nuria, he coordinates the working groups. Please, you must send you must fill the application for the project selection among the 13 projects. And now, just when Juanlu finishes the session, Juanlu and Nuria will prepare the group. You know that there is a random selection if you don't fill the application. In any case, we have a problem. No a problem. We have 13 projects, but we will have 8 groups. Then we will try, or they must concentrate you according to your 3 options in those projects with more demand. Well, today Juanlu will introduce the Agentic AI platforms from a practical point of view. Juanlu is a postdoc now in the Research Institute of DASTI. He has some double degree in computer science and mathematics, a PhD in artificial intelligence, and the current topics are associated to trustworthy AI, safety, and human collaboration, and also in Agentic AI. And today he will introduce the platforms that they are very important for you if your project is focused in real problems applied or with application of Agentic AI. Juanlu, please.
Okay. Thank you for the introduction. So, as Paco said, I will be talking today about Agentic AI platforms. And I have approached this talk from a point of view of analyzing the main features that we may be interested for an Agentic platform. Then we will go deeper into one of the most popular platforms, and then we will have a more brief review of many more of them, with a finally analysis of all of them. Okay. So well, these days, with the boom of Agentic AI, a lot of Agentic platforms have been developed. We have an interesting fact here that 62% of the organizations, enterprise, etc., are already experimenting with AI agents, and 23% are already scaling Agentic AI systems. So, as we are moving each time more into the Agentic systems, the platforms are becoming essential to build them and to control them and to deploy. Okay. So, what are we talking in this talk? As we said, there are a lot of Agentic platforms. How can we try to choose the most appropriate for our needs? That's the question I'm going to try to answer, at least partially, in this talk. Okay? So what things can we or should we consider to choose the right platform? Here I will be talking about several dimensions, like several degrees of different areas that we will see in the next slide. And then also a lot of features of the platforms that may be interesting depending on what we want to develop. Okay. So the first of these dimensions I have selected is the purpose of use. Okay. Agents can be used for a lot of things. In our area, we will be focusing mainly in research. In the other side, we have the user applications that made by enterprise that can be applied to many things. Also, the primary user who will be working in the development of the app. We can think of AI experts, then software engineers, and on the other side, we can have technical experts of the domain with a little knowledge about computing. We can think, for example, in a medical area, biology engineer, and on the edge, we could have the non-programmer user, which may need another type of tools beyond programming, like visual interfaces, if they want to make their own system. Some additional dimensions we can think about are the full control of the system versus the convenience of the tools we are having. If we are working in real applications or just we are happy with prototypes, the portability of the model, or if we just are fine with one ecosystem to work there. Also the single agent versus multi-agent paradigms, and the expectancy of life of our application. And beyond these dimensions, we can also think in a lot of features. Okay, here we have all of them, and now I will be discussing in the next slides a little about each one. First, we have the platform standards, how the workflow works in that platform, the language providers, how can I use them, how easily can I use them, tool use, essential for the agentic systems, multi-agent coordination, the protocols that can I use or I can easily use in the platform, memory management, retrieval, augmented generation, if I have any kind of reasoning or planning control of the systems, also human in the loop, observability or explainability, also topics that safety of the systems, privacy, interfaces to work beyond programming, and finally the deployment, the scalability, and also if we have any optimization tools for our system. Okay. So, well, several main standards for a platform. The supported languages, we will be focusing, for example, here in Python, so we will try to, well, most of the platforms right now allow Python as a language, so we may not have a problem with that. Also, open source may be interesting. The main purpose of the platform, which, well, developing agents, but depending on the platform, they can be more oriented to different things. Then, the first feature, workflow, architecture, and orchestration. Internally, most of the systems have a way to design the agents. We can think, for example, of graphs, state machines, pipelines. In this graph, we can also have like loops, conditional branches, So we can think about these questions. Can I, or how easily can I model my agent system as any of these things, or use that conditional loop, conditional branches loops, etc. Another important thing, the language model providers and the flexibility of the providers I can have in the platform. We can think, for example, in that, imagine we are working in a medical problem again. We have data that we cannot share to the internet, or we are working with our own language model. We have trained them for a particular case. So we may not always want to access open AI models or anthropic models, okay? So we have these questions for these cases, no? For example, how easily can I use commercial language models? Probably most of the platforms support them. Depending on the platform, it is true that, for example, the OpenAI platform will be more focused on OpenAI models, but they usually allow a lot of more models. How easily can I use locally hosted models, for example, using Olama? Define a new interface for a new language model I have made myself for a specific purpose. We can also think about multimodal models for some applications. And also, how easily can I control the parameters of these models? Do I have functions, tools to do that? Next important factor, the tool use. As I said before, it is essential for Agentic platforms because it is the step to bring language models to agents, no? To interact with the environment. So how easily can I call a tool? Usually it's very easy in most of the platforms. How easily can I define my own tools? Also, usually it's easy. It is also interesting if the platform has a good library of tools already implemented. Also, how easily can I use external tools from other libraries that are exposed on the net? And if I can control the effects of these tools. No? We will also discuss this topic later, but here we will talk about, we can think about permissions of a tool, if the tool needs approval before getting used, retries, logs of the tool use, etc. Multi-agent coordination can be also important in a lot of applications. The use of multiple agents is increasing in this type of applications. So how easily can I, in my platform, define multiple specialized agents? How can I also define how they interact, if they delegate one on another, if they have peer-to-peer collaboration strategies, if there is an orchestrator, okay, or a sequential pipeline. Also, can I connect with existing external agents in an easy way? And also, as before we said with the tools, can I control the effects and the coordination of the agents? So these are questions that we will try to see them in several of the platforms, okay? Okay, so Continuing somewhat in the topic of tools and agents, we have also the protocols and interoperability between the agents. Usually the platforms have their own tool libraries, their ways to define multiple agents in their own library, but how can we also connect with other tools, use other tools from other libraries? How can we discover other agents and contact them and interact with them? For that, we need several protocols. The most used protocols right now are the model context protocol to use external tools, and the agent-to-agent protocol to interact with other agents and also discover them. So we may have to think about if the library we want to, the platform we want to use allows for these protocols, or how easily. Another interesting feature is the memory. We can have a lot of types of memory in our agent systems, short-term or conversation memory, the long-term memory that remembers like previous conversations in a whole project, for example. Also use patterns, how should I use some tool knowing what happened before, okay? So here we have several questions about the memory. Can I use easily short memory, long memory? Separate the long memory between user memory, semantic, episodic, procedural memory. Also an important thing, how easily can I control the memory, what to remember, what to retrieve later, what to forget in case I need to forget something. Also, can I have individual memories or shared memories for every agent? And according to privacy as well, which is a feature that we will see later, can we prevent sensitive information to be stored in the memory? Next topic, the RAG, or Retrieved Augmented Generation. Again, it may be important for many agent applications, so I should ask for the platform if I need to use a RAG. How easily can I, for example, ingest data from PDFs, website, databases, APIs, cloud, or any internal repositories? Also, how easily can I manipulate, for example, in PDFs, the chunking, the metadata extraction, the embedding generation for the retrieval later, combine vector search with keyword search, and all these strategies. Also, can I work with different bases simultaneously or how easily can I do it? And finally, how easily could I trace the retrieve source so that then also I could also explain to the user why I have output a certain answer. Another interesting topic, the reasoning and planning control. So in this, under this question, we should think about how easily can we make our agent think, or think in a certain way, like the chain of thought, react, responding over a tool use, or tree of thoughts, or anything. Can I do something like that beyond system prompting? So we can, or also, can we have like critic, verifier, evaluation, reflection steps? Another question, if I need human oversight, can I manage it with my platform? Pues here we have several questions about it. Can my platform allow me to pause the execution when I have high-risk actions, like tools involving several risks? Can I ask a human to approve or reject some question? Can I resume the workflow later and define several approval policies depending on the risk level, the tool, the user role? Okay. In terms of observability or explainability, most of the platforms will focus on how well can I observe or trace my answers. So we have questions like how easily can I trace every step of my agent, replay the failed runs to analyze them, export the traces, show some summaries of the agent's decision processes, and also, it is not usually built in the application. Can I generate explanations in any sense from the agents? Next feature, safety and privacy. It is an interesting topic because we know agents can usually produce dangerous outputs, for example, or they can receive malicious inputs. So can I add guardrails easily to block them? Also, to defend against prompt injection, prevent sensitive information to be stored or to be leaked. Okay. And also, can we align in any way the platform with internal governance, legal, medical, regulatory requirements? We are almost finishing with the features. One of the last ones, interfaces and accessibility. This means if I'm not a programming expert, software developer, anything like this, can I also try to make my own system for any purpose? Like, do I have a graphical interface for non-expert users? Well, if I'm expert users, do I have the ability to configure everything I want? Also, for the developed systems, can I expose easily the agents through chat, web, APIs, in notebooks, Telegram, or any application similar? We're talking again about the citations. If we retrieve information, can we also get the citations or expose them easily? And we can also think in different interfaces for developers, reviewers, or domain experts. Deployment and scalability. Some questions about that. Important for the final systems. If I'm going to run an application for many users, how easily can I deploy them in the cloud? How easily can I scale my system when the need scales as well? And how well it works with long-running tasks, background jobs, queues, resumable executions, and also the credentials or secrets management. And the last feature we are talking here, related with the cost and the performance. Here we can think about several questions like how easily can I limit my model to not use too much tokens in order to not expense too much or finish with the credits I have with my model provider. We can think of that. Also, can we catch the results of the retrieval to use them later? Also, batch operation. In general, can we minimize the expenses of the language model with built-in tools in the framework? Okay, so this is an idea of all the features we can take into account to develop or to choose which platform to use for one thing or another. Now we are focusing in the agentic AI platforms themselves. Okay, as we will see at the end, there are lots of platforms right now. Most of them work very similar in most of the aspects. So I will talk deeper in LangChain, which is one of the most popular platforms right now. And then at the end, we will discuss some of the other more relevant platforms, remarking the differences or the highlights that those platforms include with respect to LangChain. Okay, well, when we talk about LangChain, we really talk about the full Lang ecosystem, mainly composed by LangChain, LangGraph, LangSmith. Okay, here is the main information about the platform. Just a second, please. Well, the purpose of the platform is, of course, building and orchestrating LLM apps and agents. And as I said, it is divided in three main branches. We have LangChain, which is a high-level API to develop agents and model tool integrations mainly, also RAG, structured output, and app logic. LangGraph is the low-level platform that allows us to play with the graph workflow of the agent system. Okay? And finally, LangSmith is the third platform for mainly observability, deployment, tracing, debugging, etc. It is, of course, in Python. It also allows TypeScript. LangChain and LangGraph are open source. LangSmith is more a web platform that we will also see later. They are free to use, but there is also a paid version for LangSmith with more possibilities of traces and deployment. And here we have a lot of integrations, things they can do, and production features. Okay, so all the previous features we are going to see now them. How can they be translated to LangChain? Well, here we have, for example, how the workflow works. The workflow is controlled in LangGraph, the low-level interface, and allows us to make graph structures to define different agents. There you have the code. Maybe it is a little small, but you have them in the slides, which are shared. Okay. Well, the idea is at the nodes I want for my system, at the edges, the connections, and and the conditional branches to define my application. The agent definition and language providers in LangChain. They are easy to use. LangChain has interfaces for Olama, Anthropic, OpenAI. They also allow us to define my own class for my own language model if I need. And the agent creation, it's pretty simple. It is usually simple in most of the platforms. We have there an example. It's just using the function create agent, selecting the model, the tools I want to use, the system prompt, and then just start working with it.
Excuse me, when you say maximum token, that's maximum token?
Sorry, the microphone. Okay.
When you mention the maximum token in cloud and OpenAI, that's you mean maximum token per prompt or what?
I think so, because of the size, I think it is per, but, well, I could say the documentation, not sure, but I think so.
Mm-hmm.
Okay.
Thank you.
Okay, so we finished with this slide. So the tool use usually very similar also in other platforms. Usually we have to make just the function with the tool to use and then send to our agent we want that tool as a parameter. Many of them specify a decorator, the tool decorator, for example, for LangChain to use them. And we can also add wrappers for the tools, for example, to check permissions. Imagine if for some reason I don't want to allow a tool in certain situations, I can add a condition to block that tool if it is triggered in that situation. Multi-agent coordination, it's allowed in several ways. I can, on the one hand, use directly LangGraph, the low-level interface, to model the graph as I want. And I can also program the typical patterns via LangChain. These patterns are sub-agents, where I have a main agent that receives the request, and then, well, maybe it is not very big, but I will try to explain it by word. In the sub-agent paradigm, we have the main agent that receives the request, and then it asks the other agents, specific agents, to finish that request depending on the topics the user has asked. In the handoffs pattern, there is also a main agent that receives the request, but once it processes the request, then it delegates to the specific agents, and then they do all the work. In the first one, the control returns back to the main agent. In handoffs, the control doesn't return. The skills paradigm, it's like a single agent strategy, but the agent changes itself, loading different skills according to the initial request. And finally, the routing strategy, we have, instead of an agent, a routing language model that receives the petition and transforms it in another query, text query for the sub-agents. Well, The need for using one or other strategy relies mainly in the number of calls the agents may need. Okay, so depending on the application, sub-agents may need less calls, and in other applications, it will be the opposite. In terms of protocols and interoperability, LangChain allows connection and deployment exposement of model context protocol servers. So we can connect to another server, get their tools, or we can also expose our own tools. The agent-to-agent is not directly wrapped as a function in the library, but it is not also difficult to implement it with the agent-to-agent tools from other libraries. Okay, and if we deploy an agent server, it I think automatically expose an agent-to-agent endpoint for communication for other servers. So to have my own A2A server, it is easy. In terms of memory and states, the platform allows us to use both short memory and long-term memory. The short memory is stored or used with a checkpointer structure. For long-term memory, we have the so-called stores. Okay. If we want to remember, forget, recall, or update memory, the suggestion is to build tools for that. Okay. And we can also have, the library also provides a middleware for automatical summarization, for example, for long conversations, to store in memory as a more as a shorter information. According to RAG, the platform also has the tools, the functions to make it work. Maybe it is not as immediate as other platforms. There is a little manual work. For example, here is an example for a PDF. We have to go step by step. We have to define our embeddings model, define our vector store, I think chunking or processing our PDF to start information, and then we define our agent. We can add a context variable to it, so to make it work with that context. About reasoning and planning control, beyond system prompts, an interesting thing LangGraph in this case let us to do is to wrap the reasoning as another graph. So we can have a lot of states modeling that steps of the reasoning, or like several nodes, like a generator node, a critical node. For example, we are thinking in a tree of thought, to put an example, and construct a graph to work in this way. For human control or human in the loop, the platform has interesting tools. The middlewares I commented before for summarization are also useful for other things. They basically act inside the agent use and can modify its working. In this case, we have human in the loop middleware built in the platform that allows to for a specific tool to define an interruption point, and then we can process that interruption and ask a human if they need for approval of the tool use or rejection. In terms of observability, we move now to Langsmith, the third platform, and in Langsmith we have the opportunity to check, for example, all the tool calls, all of the agent steps they have made, and analyze them with a lot of variables. And an interesting thing is that to do this, we just have to add an environment variable with the Langsmith API key, which, well, there is a free version, so we don't have to pay for that key. And well, they have some tracing limits, but in theory, we can just, for little applications, work adding that environmental variable and tracing there. Well, in terms of safety or trust in the models, privacy, the platform offers mainly on possibly terms of privacy and safety. On the one hand, the possibility of building guardrails, for example, for filtering ROM outputs of the models or malicious inputs from the users, and also a lot of middlewares as well to prevent, for example, personal information to enter in the models. Also limiting the number of tool calls in case they are to avoid, for example, loops or well, too many tool calls, because they can be also a problem in several applications. They usually shouldn't need very much. So we have a lot of middleware for privacy and guardrails for security, for safety. In terms of interfaces of the platform, we have several ones. We have from Langsmith, Langsmith Studio for development and debugging, mainly of the networks of LangGraph. We have also a Langsmith UI for observability and tracing, and we have also third-party platforms that build over LangChain, like LangFlow or FlowWise, that also allows us to define models visually with a visual interface. For the deployment and scalability, the platform offers us the engine for the execution, which is called the agent server, and the platform where this engine runs, and the agents deploy, and also scale, which is in Langsmith deployment. In terms of tools to reduce cost or to optimize the token use or the agent optimization, we talked before about the tool called limit middleware. We can also limit the number of model calls. We have also the summarization and middleware as well, combined with the memory. We can also add wrappers on the model calls, like for routing. For example, for one task, I just need a small model, let's use it, and for other tasks, let's use the bigger model. And we have also tools to catch past queries that are similar to the newer ones, so that we don't need to go through the model again. Okay, with this we finish with LangChain, and now we will go to a brief walk on other of the main platforms at this moment. Okay, so first I will start with OpenAI Agents SDK. It is another framework to build multi-agent systems. Also allows for tools, delegation, guardrails, tracing, and support of the model context protocol. It is also available in Python and TypeScript, open source. It has only a free version, but there is here a trade-off because it is designed to work mainly with the OpenAI APIs. Well, a lot of integrations again, and a lot of production features. Okay, so in general lines, it works in the same way as LangChain. We can define our agents, add them a model, then we can use memory, define multi-agents, use RAG, a lot of things. And a few differences to highlight. For example, first one, like not a drawback because it can also be done, but it is not as easy. Is that this platform is focused on the OpenAI models. So if we want to use a cloud model, an Ollama model, it will need a little more work, but also not very much as well. The long-term memory support, it is recommended to use databases. They don't have a native structure like LangChain. And other different things. They have predefined handoffs system for multi-agent collaboration. LangChain talked about all these agent systems, but they suggest to implement them programmatically. Here we have already this approach, and we just have to add a line to the code. A lot of built-in retrieval augmented generation tools. Okay, so it is less work in that way as well. Another highlight is the power in traceability and observability with a dashboard application that can be used. Next one, the Google Agentic Agent Development Kit. It is the Google version of agent development. It again allows for using tools, developing multi-agent systems, etc. Also available in Python, TypeScript, Go, and Java. Open source with a free-to-use version. There is also an enterprise version which allows the deployment of big systems. Benefits from the Google application, a lot of Google integrations that can be easily done. And I think there is a talk about Google platform next day, so they will talk a lot more about this topic. A few features, the natural agent-to-agent interoperability, since this protocol was developed by Google. Also, the natural access to most of the Google Workspace tools and the Google Cloud. They have a lot of predefined agent orchestration, so we don't have to make them manually. In terms of like the OpenAI platform, there is a similar inconvenient. Well, not that much. It is model agnostic, but they also have a little more work if you are not using a Google model. The human-in-the-loop mechanisms were not developed very much until the version 2.0, which now is in beta. Next framework, we have the Microsoft Agentic framework that is the successor of two platforms existing before. I think they are still there, which are AutoGen and Semantic Kernel. And they are generic approaches also for agent and multi-agent workflows, maybe with more enterprise support, also supported in Python and C hashtag, open source as well, free-to-use version. They have paid features or extensions to use Foundry agent service of Azure, a lot of Azure integrations, several production features that are interesting. As Google was powerful with the Google Workspace, this platform is powerful on the Azure ecosystem. Okay, it also allows for predefined agent orchestration. They can be defined in easily. Here we have an example. It has been released really recently. I think it is from April, so it may be still subject to many changes between versions. Another thing to comment is that maybe they don't have as middleware as LangChain to control the agent way of working. This is the main information of the Microsoft Agentic framework. We are going to talk about maybe the two other more important frameworks of the moment. We have Creo AI, which was discussed yesterday in a talk. This is a different approach or a different strategy to orchestrate the agents. It is mainly oriented to multi-agent workflows. As it was explained before, it is oriented to roles, tasks, even crews to develop the multi-agent systems, as well open source, free to use. They have a paid enterprise version. Maybe the main features are the difference in the multi-agent strategy. And we can also comment the last platform of the top 6, Llama Index. This is also a platform with following a different approach. Okay, it is mainly oriented to retrieval augmented generation. Very powerful to work with documents, data connectors, indexed retrieval, and building agents for those topics. Okay, also available in Python and TypeScript, open source and free to use. Can be extended to use Llama Cloud and Llama Parse. And the main integrations are all related to PDFs, databases, connectors. and the main production features also highlight the retrieval augmented generation. And many more, because there has been these years a lot of development. For example, the Hugging Face library, small agents, Pydantic, I think is this one, Haystack, Mastra, and still there are more beyond them. Some, well, small platforms also oriented more to research. We have specific multi-agent frameworks that, for example, Camel, it is a platform more oriented to research. In scaling agents, they have tools for easy creation of multiple agents and roles, simulation, data generation, automatization, and also, well, they have dynamic communication features, allow for memory shared or individual, and scalability. MetaGPT is another framework, a curious framework that models like the roles in a software enterprise. So at a query, they launch their agent, their software engineering system to mainly develop codes, data analysis, and those type of things. Okay. Well, OpenAI Swarm is like a previous version of the OpenAI Agents SDK. It's a lightweight framework mainly for orchestration, and that is right now it is usually used to examples and small study cases. This is about multi-agent workflows. I have focused on code-first platforms because, well, for our needs, I think it's the most suitable thing. But we have also low-code or even visual platforms. We have talked before about Lang Flow or Flowwise, which were interfaces for Lang chain. For example, we have here also Besser, which is a platform that next week you will have a talk here explaining the platform better. And it is a fully platform to develop agents visually or with very little code. Okay, it is not only available for agent generation. They also allow to build code, normal code from UML, diagrams or similar, even for quantum computing and many other applications. And well, just to mention them, because I thought that it was interesting to talk in a talk about agentic platforms. Not as related with the other ones, but we have also a lot of software agents that I'm pretty sure most of you already know, like Codex, Cloud Code, the GitHub Copilot, we can consider them already as agents, ChatGPT, Gemini, Cloud, and well, OpenCloud, for example, like a personal agent that has also become interesting recently. Well, just to finish, a few final insights. This is from personal experience, from what I have been seeing while I was preparing this talk, about the initial dimensions I commented, about which is the primary user who will work in the development or the purpose of use. Here, as I said, there is my personal feedback about this. I will place, for example, LangChain or the Lang ecosystem, the first we talk about, nearly in the middle, because I think it is from the commercial or the most popular platforms, the one that allows to go more in both directions, like for research and for the application development. The commercial, well, the OpenAI, Google, Microsoft platforms are more in the consumer side. They also offer more powerful deployment platforms. So that's the idea of being there. Well, the visual interface, of course, are more focused to non-programmer experts, as well as for, well, consumer applications. For example, I don't know, in the case of a hospital, to make an agent system for a specific purpose, an agent application. Then, for example, the Camel ones, MetaGPT, may be more focused or can be more placed to the research side. Also, maybe require as well higher AI knowledge, while the OpenAI, Google, Microsoft, and even Lang are in the just with the programming ability skills. I think they can used in a proper way. Then Llama, well, the remaining ones are also in the middle side. Well, between these two dimensions, there is a, in my, as I said, this is my personal feedback, a correlation between the level of expertise and the level of research of as the purpose of the application. Also, a final valoration, you don't have to pay too much attention to this, because it's a lot of platforms to evaluate. So, well, the summary is that the main ones are very powerful in most of the aspects, with 4 or 5 stars in almost everything. Well, the visual ones, for example, are better in the terms of user interfaces, are weaker in other things because they allow us for less handling. So here, well, that's the main idea I wanted to comment here. Of course, again, it is a personal valoration while working in this talk. And also, well, they are very powerful, but they still can be improved. No? So, well, something that it was planned before, it could be possible to develop an ideal platform for example, research. Maybe there is room for that. We could focus in several features and try to focus on those ones to develop an ideal platform. So, well, the conclusion is that maybe we can still have more platforms focused on the purposes, well, several purposes. For example, research. Maybe we can still have several ones. And that's all. So thank you very much. And if you have any questions.
Gracias. Thank you, Juan. I would like to ask you, please, can you go back to the previous one, the previous one, this one. Here you have a classification or a taxonomy with the purpose from pure research to consumer application, and you have from no programmer users to AI experts. I am checking that when you think to use from the research point of view, you need to be an AI expert. It has sense because you are using the platform for research. Usually you are an AI expert theoretically because your interest is to research and then you have experience in AI. But you have on the right, and from non-programmer user, Besser, that is a platform, you have been working with Besser, and we will have a presentation of Besser next, an expert of Besser from Leaks Lab next week. I would like to know your opinion from the point of view of the project. I have here the list of the project with more attention. For example, the project with more requests. I must take care with the laptop, sorry. Sorry, the laptop is survived. The project with more attention is explainability. Please, from the point of view of explainability, that there will really 10 people propose explainability as first option. Then, this is a spoiler, then our idea is to have two things with explainability in order to provide the possibility to have to work. What is the platforms if the things considered are real problems, are real application, or here tomorrow we explain how they start. Is tomorrow or after tomorrow here? After tomorrow, Thursday. Thursday or here we explain how they consider a real problem in his project and the way to construct the project with a real problem. Oyer what was the topic of your project last year? Initial topic, do you remember? Was associated partially to explainability because they were working in explainability. The project of Oyer, a spoiler of your presentation, finally Oyer will, and the team of Oyer, they did choose a real problem and analyze from explainability point of view the real problem. And they did start with a real problem. And then later, as Oyer we explained, the project attracted the attention in the journal because they start from a real problem and they develop a theory associated to the real problem. Juan Luz, from the point of view, in the other slide of here, I don't know, what do you suggest if the things propose explainability? Of course, are people with experience in AI. What is your suggestion? Because I'm checking Camel, Meta, is they are from the Camel can support any kind of language model, I suppose. What do you suggest for explainability and other kind of? What is the second one? The second one is human oversight. The second one is human oversight, and the third one? Auto-distribution. Auto-distribution was not the fair option for so much people, only 2 people, but was a second or third option for a lot of people. But the best, the fair option are explainability, causality also has, the fair option was explainability. Also, human oversight, governance, and RAG, causality and RAG, and reasoning. What is your suggestion for them? Because we like Besser, you have been working with Besser. Besser is more require less technical knowledge. Really, it is an advantage to develop an application. What is your suggestion for them, for the teams?
Well, Besser maybe it's too visual for digging into those type of things. The research area there with Camel, MetaGPT, maybe it's they are platforms developed for researching, but maybe they are too niche. So, or like you research in the specific topics they were designed. I think most of them were multi-agent interaction. So maybe I would choose the Lang ecosystem because it is the most centered one. It is good enough if you have programming skills. And between the big four here with Lang and the OpenAI, Google, and Microsoft, I think it is the more oriented to research without forgetting the consumer area, because the other ones have more powerful interfaces for deployment. But LangChain, it is like the equilibrium between the ability of doing a lot of things in the platform and a good deployment ability. So,
okay, thanks. One question. Last year, we were checking. Last year, we include in the same topic human collaboration. This year, human oversight. Same, in the same area. We include together explainability, governance, and human AI collaboration. This was the topic of OIR. OIR is working in governance and auditability, and they choose explainability, this topic. Well, this year we separate, was the proposal of Juan and Nuria. They separate the problems, and we have explainability, the first choice, with 10 of you has the explainability as the first option, and other 10 of you as second or third option. Really, we will have two teams, and people with the first option, probably all of them will be in explainability. Second option this year is human oversight, and human oversight associated to human AI. I think that it, and the third option is near to the third option. Okay, auto distribution with a few requirements. Only two people auto distribution as the third option, but a lot of people in the second option. Causality and governance. This year governance is different. My question: if you are working with governance, Juan, I understand that, for example, Besser, that is a good platform, very easy to prepare an application with Besser. Probably, if they choose a governance, there will be a team with the governance. To work with Besser may be a good option, because really, from the governance point of view, the problem is similar with the distance among them. The governance is a global problem of AI system, and to have the rules of governance. For any problems, if you choose a real application, we need to develop the governance methodology, a governance pipeline. Do you think that Besser maybe, for example, better for governance, and Camel, if they want to think in a potential project with future work and to continue the collaboration in the future for explainability, or even Besser with your experience with leaks, the labs, maybe also useful for explainability. In your opinion, that you are expert with Besser and you are working with Besser, do you use for governance? I suppose the answer was yes. For explainability, do you use Besser also? Do you think it's possible to introduce algorithms with explanation inside of Besser? What is your opinion? Because you are working with the people from Leaks, the labs from Luxembourg.
Well, I think they are keeping with the updates of the system. Actually, I entered yesterday, and there were more features. But, well, from the visual interface, just from the visual interface, it will be a little difficult right now, I think, but it can be complemented. They have also code below that visual interface, so with that help, it may be possible. Although, well, I think in general for most of the applications, I would say long chain should be the most neutral option. Or
yes, it's in the middle between research
yes.
and consumer application. But for governance, in theory, for the governance topic, any one of the platform may be useful, because really the governance, you are thinking on the problems, the agents, the cooperation among agents, and then to govern the guardrails and to govern the model. Probably for governance, any one of them may be useful, no?
Well, yes, maybe.
And for, in your opinion, if the two things, and there is another thing that choose causality. Causality has also a lot of requests. Causality and explainability, they are both together in the area of explainability. Causality is associated to explainability, but from a quite a different point of view. Explainability from a post hoc way to understand the decision, and causality checking or understanding the problem, the connection between among variables and so on. Then probably for explainability and causality, your suggestion is a long graph that was a long chain that was the first one that you introduced. You like for research, you like this platform.
Yes,
maybe easy to include and to develop modules for these topics.
Yes, I will choose that because the more flexibility it has on most of the areas, so that can be then used for the different applications.
Let's suppose that one team present explainability with long chains. I understand that long chains can be connected with any one of the LLMs. If you have an account in, I have an account, for example, in ChatGPT, personal account, and we have an account from the university with the Gemini, sorry. In this case, and we have in today's a talk about Gemini and Gemini agents. If you have an account with university, that I suppose in other university we have also the account of people from here, from Granada, is possible to connect long chain with this account, or do you need a professional account in order to develop application?
Most of the, for example, OpenAI, I think even you are paying the ChatGPT Plus, if you want to program with an API, you need to pay.
You need but you need the pro version, not the personal version, in order to connect the agent.
Maybe, I'm not sure.
Probably with the personal version is really the low cost, and the agent consume a lot of.
But
sorry.
€100 per month.
100 euros per month, the pro version of ChatGPT. Okay, my personal version in Spain is 24 euros, I think. Is my personal version, and our Gemini version is also the personal. The university is an academic. Is not a pro of Gemini. Then really the problem is that the consumer to have the continuously the iteration of the agent consume a lot of prompting, I suppose, no?
Mm-hmm. Yes. I usually, to do small experiments, use directly, Aulama language model on the local server, so I don't usually test using the commercial.
The professional. And you use the Llama that is supported in our
yes.
In our platform, in our
yes.
hardware H100. Mm-hmm. Then you have the Llama, and you connect launching and also version with Llama.
Yes, they will support, most of the platform support.
Then really the student, if they want to develop a project to present a proposal now, because now is only a proposal, an idea, and they want, if they want to develop a project, a real project along next month's cooperation, it's a good idea. For example, we have here the support with Llama, and it's a good idea to have Llama with one of the graphical card of our H100 and to connect better or launching can be connected with Llama, and they can develop directly a project with the Llama without any cost of the connection with the professional accounts. Maybe possible?
Yes, that's an option. Another option is, I think there are some language models that allow a free use for a limit of use, like X tokens. You can use them for a period of time. So that's another possibility, because well, the server models, the model hosts in our servers don't allow for a very large number of parameters.
But I am thinking the possibility that from the 7 things, you will be 2 things with explainability, 1 thing with causality, and in these 3 things, I think there is a thing with RAG that also, of course, with the RAG will work with Llama probably. And really, I think that the project, they can propose real application, real project, thinking that to continue in the future with the collaboration, thinking about an internal application on Llama, and they can develop really the project with it. I am thinking about the next time after the summer school finish next week, and let's suppose you have an interesting project and you want to continue the collaboration among you. For me, it would be excellent. We can support you, Juan Lu, Nuria, and myself, and other people from the other speakers, depending of the topics. Really, anything in the possibility, if you want to develop, to continue developing the project, you have access, for example, at what platforms, H100, CAS, and we have Llama, among others. David, Llama. It is possible. How many graphics do you need to use Llama in the H100? You are using the small model. You are using now, I remember Mistral, and also there is another possibility. We have the people from Abu Dhabi can use also Falcon, and David is using Falcon in our system, because Falcon and Mistral, they are small, they are 7B, I remember, among other, or 7 between 7 and 10B, and David is working with a small model. It's possible, Juan, also to use Mistral or Falcon. Falcon has 2 possibilities. Falcon has a big model, big parameter model. Falcon have a small one. David is working with Falcon. Even Falcon can be used in any, but with some high quality graphic cards, but without so much restriction. Maybe possible even to develop a project with Falcon or Mistral, a small language model, even try to interact for causality and explainability. Do you think maybe even to use, because if they use a small language model, it's very easy to install it. Even David, I know that is doing experiment with a big personal computer with a strong graphic cards, but it is possible to use Falcon and Mistral, but they can develop a real application with explainability or causality. Do you think?
Well, you mean if it is feasible to integrate Falcon with the platforms, or?
I think so, David. You are using Falcon in your computer, no? In your experiment.
Not right now. The last time I used Falcon was like 1 year ago.
The previous experiments. But where do you use Falcon? In your computers or in the H100?
Depends on
The site, of course. But I think so. I think it is possible to integrate Falcon.
Yes, well, in
And
any
we
case,
have. In fact, I remember we have a talk of Agentic by Marwan, the director of the project of Falcon. Then Falcon is connected with Agentic, and people from the students from Abu Dhabi can access probably a direct account with Falcon. I think so, and Suárez. I don't know the difficulty to connect better with Falcon, but Suárez it is possible, and blockchain. I am thinking about the possibility to have the access to hardware and to a small language model and develop a project a long time with this small language model. Of course, if they use a small language model, the quality may be reduced from a general point of view, but really from a practical and specific problem with an RAG, that there will be a team with RAG. I am thinking even the RAG team can be coordinated with the other things, and they will present a project on RAG, and you can integrate the RAG project to get explainability, in order to have a specific technology for a problem in the RAG, and then to introduce explainability technology in order to check the behavior. I think it's possible. I don't know exactly, but this is the now really. For then, I think you must study this possibility. In your proposal, you must propose the project. Really, you will not develop the project because you have no so much time. You propose the project. It's important. You propose. We want to integrate a RAG. We can collaborate with the team of the RAG that they are proposing the top technology for RAG. We are thinking on a particular or special problem. We can integrate knowledge on the problem in the RAG. We can connect Falcon with the RAG in order to have a specific the knowledge on the problem, or Mistral or another platform, and then we develop the directly the Agentic with connection with Falcon and with a RAG in order to focus the attention on a special problem, and we want to introduce some explainability methodology in order to explain or causality or to get the causality for the problem. Probably they must study this possibility. The project is a proposal for the future, and really they need to study how really can they connect launching better with this kind of a small platform. Of course, another possibility is to propose. We want a project working with the OpenAI platform connected directly with ChatGPT, or they can propose we want to use the Gemini and the platform of Google, but there is another possibility. They are using commercial platform, very strong or with high power and high quality the language models in comparison with the small language language model, but of course the scenario is quite different. From a more practical, direct practical application, they can propose to use the big platforms, and from a research point of view, probably is better to think about a small language model integrating with explainability. But really, we want to listen to you in the presentation about your proposal. You must develop an idea, and we will evaluate the quality of your idea, because we are not. You can develop some small experiments with the platforms, but we have not so much time. Really, basically, you present a proposal for the future, and really, it was the case of Oyer with Riscambi that he will present. They presented here the idea to analyze Riscambi, but really, after to finish the summer school, the team that with Oyer and other people, of course, the proposal was very good proposal. I remember to like so much the proposal, but later they continue developing the study in order to analyze the problem, the rescambing, and proposing the complete methodology that here we explained you. Then we want to receive proposal, ideas, creative ideas, and with the possibility to develop in the future. Yes, we are over time and we have the coffee. Thank you very much. And I hope you enjoy using platforms of presenting proposals, following the ideas that presented Juan. Thank you very much.
Welcome.
Caro, se puede.
Let's go to continue the next section.
Se puede poner.
It is really my pleasure to introduce my colleagues is coming. It's a pleasure to introduce my colleague Natalia Díaz Rodríguez. She is now associate professor in the University of Granada. She has a long trajectory with PhD in Finland, different postdoc in different countries. The last one was in Paris, and recently, fortunately for us, she decided to come back to Granada because she's from Granada, but she finished the degree and then start to study in Finland and different country. And really, fortunately for us, she decided to come back to Granada. And with a postdoc, now she's associate professor, and she's a specialist in explainability, among other topics, and particularly in Neurosymbolic. Now, just recently, she participated in a big European project with 15 million of euros. The support is really a top European project on explainability, particularly on the use of Neurosymbolic for explainability in continual learning and general purpose artificial intelligence. And just now, they start the research project with a lot of things, university, company, and so on. And she is the leader of the team of Granada, working in the topic, developing the topic. I did ask her that in collaboration with the people from the project to prepare a presentation about the topic Neurosymbolic AI, to introduce the topic and to introduce us the main goals in this fundamental area. Neurosymbolic is fundamental in order to introduce more explainability in any AI system, and really is a big challenge how to implement really and to use Neurosymbolic in the AI system. And Natalia will introduce us about that. Thank you very much, Natalia.
Thank you. Can you hear me? I think no. Better? Okay, more or less.
But it is for the
camera,
but you need
okay.
to increase the volume.
Okay. Okay, thank you, Paco, for the introduction, and thanks for inviting me to this school. It's great to learn together and share with you my research. So I'm going to talk today about explainability and continual learning in general purpose AI systems. This is within the context of our AI chair with Repsol and University of Modena, Reggio Emilia in Italy. And basically, I'm going to introduce many problems in which I've been working in the past, which nicely fit together to address with the Neurosymbolic AI. So, just a brief introduction about my international trajectory. You can see companies with which I work or collaborated with, and I did research with or had industrial contracts with for PhD in my past, in Paris, in California, and Finland mainly. I also founded the Continual AI non-profit organization for deep learning enthusiasts in continual learning. If you want to check it, there is a Slack community with which you can share events and resources. And today the talk will be around the context of the AI Act. As you know, the new European regulation puts the human at the center, and we have a series of pillars and requirements for trustworthy AI. You're probably familiar with all of them, but just in case, very brief, fast introduction. You know there is 7 technical requirements based on the 3 pillars for trustworthy AI, which are robustness, lawfulness, and ethics. And it was proposed in April 21. Now it's adopted by European Council in 2024. And we are going to be focusing over two main requirements. First, transparency, which contains explainability as one of the dimensions. And later, we will focus on technical robustness and safety, because that's what concerns learning continually over time, or lifelong learning. So you know that there is being an avalanche of papers on explainability. You probably already know how important it is. We define let's say, the definition of AI focusing on the audience. We thought that this particularization is relevant because there is no explainability if we don't address to whom is the explanation. Yes. So.
No, it's okay.
Okay. There is many taxonomies in the field, and the thing is that all this now, to me, feels obsolete. It's difficult to use these methods in current AI. Now, if we don't use a foundational model, a general purpose model, if we don't explain those, these methods are very ad hoc for very single purpose models. So even though we have different taxonomies and kind of methods for even attention models, which is the basis of current AI, rule-based, concept-based, graph-based, there is a vast amount of methods. However, it's not straightforward to apply this in current foundational models, right? So this is what I want to talk today. In a way, we are working in a big challenge because it seems somehow impossible, right, to explain such large models. Also because, not only because they are large and we cannot test all these layers at once, but also because we don't know the data with which it was trained. Okay, we know it's the whole web, but we cannot guarantee that a particular image has been used for training or not, right? So these are the main inconveniences why all these methods that used to work nice for small models or more traditional before foundational models now require some kind of adaptation to be tested on large language models and multimodal language models and other kinds of models that have the power, as you know, right? So all these methods need to be integrated there, and we are going to see a bit how is the field in this area. So the problem one I put here, we will have the two main problems, as I said, tackling the two requirements. The first one is the explainability of foundational models. So in the past, we have been addressing this problem in, let's say, more moderate models, not foundational, but can we categorize different kinds of errors when the model is compositional or neurosymbolic? What does it mean? That, for me, it means that a model should tell me, I believe that this is a bird because it has a claw, a wing, a beak. All those are attributes, and this leads to the class bird with these weights, right? And that way we can see that the detected parts support the final class, right? So this to me is a crucial step, sometimes obviated or ignored, right? However, one of the problems of this is that you just say 0 or 1 if the part is base or not, right? So I still don't love this approach because I feel it's blind. We cannot, let's say, the best models are best at detecting this pattern features, right? But not verbalizing this into concepts. So once we get this attribute, it's kind of blind. Another way, let's say, we could have also a multimodal model, right? But the thing is that how can we test that the explanation is right if we normally don't have ground truth labels, right? Or how could we represent an explanation from an expert? Could it be natural language explanation? That's normally the case, no? We go to the doctor and say, why I have this allergy, right? Or could it be a list of features or a list of value features pairs? Sure, but what's the best way to represent it? So I believe that knowledge graphs are a good way. Why do I think so? So actually, I'm not the only one thinking this. There was a whole DAX tool seminar in Germany last summer. You can see here a participant called Actual Neurosymbolic AI, combining deep learning and knowledge graphs. So in the past decade, because both deep learning and knowledge graph have evolved a lot, we have more scalable methods. They have quickly become a major paradigm for the creation, extraction, integration, representation, and visualization of data. So even though at first they were not so scalable, right now with the compute power we have, they are a very good way to represent formal knowledge, right? They can be a simpler way to have an ontology, more advanced, less advanced, and at the end they improve the explainability, robustness. They can incorporate mechanisms for causal analysis because they represent variables that we humans more easily understand, and therefore there are needs to bridge the gap between the advance in deep learning techniques and this more symbolic formalism. Of course, there are more symbolic methods, but this is one, right, that I believe can be vectorized and can be we can learn the embeddings, right, and there are many applications. So what is a knowledge graph? So here you have an example of the Monumai knowledge graph where you can have the expert, we can ask the art historian to represent the styles of Renaissance, Hispanic Muslim, Gothic, Baroque. You see, for instance, in Hispanic Muslim, the horseshoe arch, the flat arch. There are some things, architectural styles, that are shared by two different styles, right? So this is a way in which we can express knowledge from experts. So we use this use case of taking a picture of a facade and predicting the style to propose an explainable neurosymbolic methodology to correct or align the explanation of the expert, which is here, which thanks to a knowledge graph allow us to correct the explanation of the model. In this case, we use SHAP, and we compute a X-I loss function, in this case with SHAP, in which we penalize the model if the explanation is not coinciding with the explanation of the expert, right? And this way, the feedback can be integrated and improved. We can also use ontologies to describe scenes, and this has been used in a robot that acts as a tour guide in Sevilla, in the Alcázar. Or we can also use embeddings of knowledge graphs. For instance, we know that knowledge graphs are great at learning representations of entities and relations, but normally they are designed for unimodal settings. So we still would like to have like a multimodal, let's say, unique representation like in relational database, that we don't have redundant information, right? Where each node should represent all the concepts in the different realization, text, image, video, maybe audio, no? If we want to represent disease, for instance. So in this paper, for instance, they take the visual language models to align diverse modalities in a common embedding. And this is thanks to knowledge graphs that improve and make more robust, actually, the reasoning. This is an example of the knowledge graph they tested with. It's a fine arts data set where you may have data sometimes in image form, others in like where is located this art, is located in the MoMA Museum, New York, or from which school is this artist, Pablo Picasso, is member of the school of Henri Matisse, etc. And thanks to this, we can retrain visual language representations to map missing modalities. So we may have a representation in text, maybe from a library or some documentation, but this is not aligned always. So these vision language models pre-trained with vision image pairs can help enriching this let's say this multimodal representation. There is also the line of mechanistic interpretability, very hot now in the aims of explaining these foundational models. You may see a beginner's roadmap to mechanistic interpretability. You may have different methods to interpret the circuits, localizing nodes and edges of a circuit, again mapping to a graph. And you may have questions to visualize, let's say, with the sparse autoencoders, we will see after. And you may ask questions such as, does the activation pattern encode feature X? It's very, let's say, you inspect the circuits of the network. But as you can imagine, the model is complex and you cannot always test all possible logics or all possible paths. And, but yeah, they are based on linear algebra methods, and it's a line of work quite hot. You may check this practical review paper on some of these models. There is also an interesting blog from Anthropic where they show composition versus superposition, and they have some nice metrics in order to isolate, let's say, when a concept is encoded in several neurons, like in the human brain, where there is redundancy, and also measuring monosemanticity versus polysemanticity of neurons, which is kind of in conflict. We want in explainability one neuron, one concept, but this is not always the case, right? So if you want to read more, there are a lot of material here. But we will be focusing on concept-based explanation. Why? Because I think that all the methods that are there still are very based on pixels or words, or let's say difficult to control by humans, right? If a pixel changes or a word changes, does it really change the explanation? This field of human level explainability, let's say that the common theme to all these methods that you can see on this survey, ACM computer survey, concept-based explainable AI, the common thing is that the concept should be easily understood by humans, right? Normally we will have some extraction of concepts in the middle and then some prediction of a final class. Normally we have this separation of classes. The problem is that these concepts are not linearly separable, right? The concept, like having stripes, not stripe, they may be shared by different animals, for instance. So things get more complicated. The Platonic ideal would be something like we will have a knowledge graph and we can map the concept to the image, to the text, and unify all. Let's say the same concept could be rendered, right, in different modalities. However, there are few models. I haven't seen a complete satisfying model that does all this. But I think this is a mission worth pursuing because we want to understand as we humans. I tell you a Ferrari, and you in your mind, you can visualize a Ferrari, right? I don't need to show you. So we should be able to render all concepts as humans. So I think knowledge graphs could help. How else can concept be useful? So in this work we showed that cubic, this method can be used to detect in an unsupervised manner, let's say concepts that are biasing your visual language model. You can have linear probe classifiers to isolate one concept from the other, computing the angle of a superclass label and the concept minus the embedding of the label to know the angle encoding this label, and this can point at the closest concepts with the cosine similarity that are biasing that concept. So it's a good way to see if there may be some shortcut learned in your model. And for instance, we could see in a data set where we just separate water birds from land birds, we could find the most biasing models of this. Look, you can see that for the water birds, you have presidential judge, an iceberg, or a cloudy beach. And for the forest, you have all kinds of forest here, but very fine-grained concepts. So we may find actual shortcuts that may be actually betraying our model, right? And making a shortcut easy to explain. Other ways of concept-based explanations. This is what I call, later we'll see, a way of concept emergence. So you have concept bottleneck models, where you have two stages to predict the intermediate concepts that are useful later to classify or to use it for another output. You can have label-free CVMs. These are actually, you ask an LLM to label this concept because normally you don't have these labels. And sparse autoencoders are also still very useful. They are the opposite. Instead of creating a narrow, let's say, in concept bottlenecks model, this embedding is, let's say, compact, like a bottleneck, while the sparse autoencoders are the opposite. You have very sparse, larger than the input embedding that allows to, let's say, have more isolated concepts. So they are kind of opposite ideas, but the idea at the end is serving interpretability. There are different applications in which you can use it in discriminative or generative tasks, the concept bottleneck models. You can see the article, What's in the Bottle, here. And there are other methods also, like concept activation vectors, concept embedding models, and other models that are really tailored to build the knowledge graph, because normally building the knowledge graph is quite difficult, but you can also predict, let's say, have two entities, two nodes, and based on Wikipedia, DBpedia is the semantic version of Wikipedia, we can pretend we don't know the edge in between two nodes, or we know the edge and one node and predict the other edge. So we can use this pre-training task also to learn associations between concepts or relations, right? There is one problem, even though they are very, very hot, or like kind of one of the state of the art in explainability. In this paper, they show there are many problems also with these models. They are not the panacea, right? So the first one is that they may be very accurate despite irrelevant or random concepts due to concept leakage. This is because LLMs have seen all data in the past. We may not know if they have seen it or not, so they may be cheating. The second problem is the linearity problem, which says that if we overlook nonlinearities here, and we simplify them to, let's say, this, if we ignore these nonlinearities, we reduce the CVMs to linear probes, which loses precision, right, and semantics. So this depends on the training set. Then there is the accuracy gap, that a CVM layer normally leads to accuracy gap with respect to opaque models. And the fourth, let's say, problem that needs to be tackled is that although they are modular by design, the evaluations do not consider different encoders choices, right? So there are many areas to work with. So it's still an interesting area, but they are not perfect. So if you're interested, that paper can help. The main problem with all these models is that they require normally some kind of labels to assure that the concepts you have learned are correct, because normally you may come with a concept, you have to inspect one by one and look, okay, this is the nose of a dog, or this is a part of parts of object, right? But if we cannot name them, it's hard to know what is learning. Also, slot attention models are similar, object-centric, but they are not concept-centric. What does it mean? That they may, you take a picture, you know that one object, another object, one poster. In the next picture with a poster, the color assigned to that object will be different. So it's not learning any semantic meaning or association. So it's just in a per sample base. So There is also a lot of inconsistencies. If you train the sparse autoencoders on the same data, they learn different features. So just changing the random seed, maybe it's normal, but I don't think it's a useful method if this happens, because for me it's not trustworthy. Like if I change the random seed and the features are not reproducible, I don't think we should be satisfied with that. They could also learn the same features, but they are kind of finicky. So what benchmarks can be used to test multimodality and to assure this coherence in these models? So there are some benchmarks here. You can see this benchmark measures cross-modal inconsistencies. You may have one representation aligning with another that they are very close, because it's the close you get. They are trained with the nearest neighbor objectives, but they may be completely different in text. The concept in text and the concept in image may be completely different. There is also, for instance, in video LLMs, you can track, let's say, in a video which parts are important, or how informative is this in terms of human concepts. So you can map the flow and see on which layers of the LLM, when does the black cat appear in the video. You can say at the beginning, at the end, in the middle. So you may try to track when these neurons activate to learn about the position, right? But methods like this shouldn't be alone. It should include some kind of concept-based explanation, right? This is still very broad and loose, making these questions. And I advocate that we need still to integrate this concept-based explanation in all these larger models, as well as symbol emergence that I'm going to show now. I also think that the explanation, if they cannot be argued and reasoned, I don't think they are fully satisfying, right? So here you can see some of the models. For instance, they show that when you tell the model, let's think step by step, the model performs better. But what is triggering that? Let's say that there are many obscure questions that we should still study. We can also see that the reasoning abilities are inconsistent. They may improve easily by just asking this special request or thinking mode, but for instance, changing variable names of Jose for Paco, we change the problem and the answer is completely different. So it means the model is not reasoning, it's just memorizing, or maybe saw the problem in the past and just knows the answer, so they are not trustworthy. We also saw that coding up a solution to answer abstract thinking or abstract problems can help. So if you ask to write a program to solve the problem, it also helps. These two papers show a bit these limitations on reasoning. I have a PhD student working on this and how the System 1, System 2 thinking from neuroscience could somehow balance between this fast thinking and slow thinking. In terms of reasoning also, we have submitted just recently, a few days, a new benchmark for sign language translation and understanding, where we realized that the models, we ask how good are LLMs at translating sign language. And we realized they are pretty bad. Like, actually, if you send a video for multimodal or video LLMs, they can do a very good translation, like the Blur, Rouge machine translation metrics are quite high. But if you ask them something like this, in the video of signing language, the woman may be saying during the day in the south and in the center, sometimes dense fog patches, because it's a data set of the weather. It may translate wrong, and then you ask which weather phenomenon is mentioned. So it's dense fog patches. So you may realize that this question, or like at what time of the day is it raining, right? It actually doesn't understand it. So it does the translation good, but then if you ask what it saw, it doesn't know. So this is a bit puzzling. And so we created a benchmark of these two data sets to, in a way, assess this reasoning and thinking and understanding. Let's say we call it sign language understanding of models. There is some tools for LLMs. Actually, I found two that are maybe you know more, and we can talk about them. This one is Neuropedia, but you may see here concepts highlighted of important ones for a given task. Different activations in layers for Gema too. However, this is a proprietary system, you cannot dig inside. And then related with mechanistic interpretability, we have semantic lens, which is another tool from the Explainable AI group in Berlin, which is quite nice in terms of interactivity. You can search for a concept given a data set and given a multimodal model, like a visual language model. You can see how the concepts are organized by inspecting the data set encodings. If you go into the website, Semantic Lens, you can choose one of these models, like CLIP for chest X-ray, for skin lesions, typographic attack, and gender bias. And what I was surprised to find is that I upload a X-ray image, as you can see here, and it kind of, if in the training time, there is some concepts that were spoken about the image, they are likely you can search for them. But the funny thing is that I see here no finding cardiomegaly, enlarged cardiomegaly. I'm not a radiologist, but I see there a pacemaker, and it's not in the concept. So I'm not sure how this is working. So I'm a bit intrigued. I encourage you also to dig further, and because clearly there is here, if these are the most important concepts, perhaps they have been filtered out as not relevant for the task. And what if we don't have the name for a shortcut learn? What if there is a new cancer or a new tumor developing? I would like the model to tell me there is a new concept for which you don't have data, that you probably should look at this. So I think real models are not ready for this, and this is what motivates the symbol emergence problem that I will talk about soon. Okay. Other ways to extend the vocabulary. So this is what we want. We want the model to tell me, hey, I found a new concept that I don't have a name for it, but it's relevant. Perhaps it's a shortcut, perhaps it's another kind of another concept, but I want it to explain it to me in concepts, in terms of concept that I can understand. So one way to, let's say, enrich the models that are there, or like we have visual language model, we just got accepted this paper in ICML with David and Roberto, in which we reuse an image encoder where from ImageNet, for instance, very rich but unimodal, and we take the rows of these weights as semantic prototypes. The proposal is that normally these weights are thrown, so we call them weight recycling because they are normally not used, and we use those as those classifier heads that you can see here to as prototypes. So we compare this with the accuracy of a direction-only classifier of the cosine on ImageNet, and we show that the performance is almost the same as using the traditional way. So we show that this acts as semantic anchors, right? And we also show a metric in which the mutual nearest neighbors here, this metric measures whether the neighbors of a class in one space match the neighbors in another space. In this case, the text embedding space. So we find that the neighbors of a class in the weight space are more similar to its neighbors in the text embedding space than those derived from image representation. So this allows us to use this for post hoc alignment without having to train from scratch a multimodal model, let's say all the image pairs of very concrete fine-grained concepts, which is very costly and only big companies can do. And we can also use it for data augmentation of image text pairs, because normally we have here the image text representation pairs, but we may have another domain that is much richer, for instance, medical domain, no? So we may use a smaller model trained before and just merge these classification heads, use them as semantic prototypes. And this we show with multiple experiments that is beneficial. So yeah, okay, we saw a bit the problems on explainability. Now, other problem is continual learning in foundational models. This is related to requirement 2, as I said. And you know there is forgetting in pre-trained models, there is horizontal continuity, vertical continuity. There are many models that you can look in this survey for addressing this. They are also being adapted to the foundational model fields. And there are different definitions of how these settings should be evaluated. There is parameter efficient fine-tuning, like LoRa, different test time adaptations in order to avoid retraining from scratch. And also, model steering is a different way to kind of readapt your model to a given domain. And then the model merging and task arithmetic, which looks like magic a bit, but it's very promising field in which we are also working and helps adapting models without retraining. Where you can just combine different fine-tuned models, sum them, and have a model in which you add knowledge. Or you can subtract knowledge and forget different concepts that you learn. So if you want to read more, you can read this paper, Editing Models with Task Arithmetic, in which you can do task analogies. So, okay, it's what's the panacea for all this? I don't have a solution, but if I have to bet, I go for NESI explainable AI. Let's say the neurosymbolic AI generically has a lot of power to have the best of both worlds if we want to keep somehow explainability and performance. I don't know other technique that could help us more, but tell me if you know. These are papers of the past that we have been doing, but now, how can we do it in today's world, like after GPT era? So we wrote in this retreat in Germany. It's a castle in the middle of the forest, very nice. You live together 1 week. There is nothing to do around, only a hike and get lost in the forest. So we wrote this report that just came online. We need a NESI theory. So this paper you can download, it just got online. We list all the challenges of today's neurosymbolic AI. Symbol emergence, small data, neurosymbolic AI, how ontologies can help, cognition and neurosymbolic AI, a more neuroscience perspective, and real-world applications. So I focus mostly on symbol emergence because I think it allows us to explain things that we still don't know, and that's where AI could help us the most, or I feel that we still should learn more. neurosymbolic system, you have learning and reasoning. In a hybrid system, it's not written how you should combine both, but you have both. And each of them will have, of course, the two parts. So you get the best of both worlds. And how to merge them, there is no principal approach. There are many approaches. The aim is to, of course, have the best of connectionist approach or neural approaches and the best of symbolic reasoning with knowledge graphs or logical inference. So the ambition of neurosymbolic system is to find, let's say, properties here that from a mapping of neural and symbolic systems, where P is a procedure that establishes these properties, and S is a let's say, mapping from tasks and domains in which that properties hold. So how to verbalize new knowledge learned when we have no name for it, or no concepts, symbols to label it? So this is what we frame or call the symbol emergence problem. So you have a symbol, you see a symbol that you have never seen, Apple, is unknown, a symbol emerges, it's grounded into the internal representation, you create a new node, and then when you see it again, you can recognize. First comes symbol emergence, and then comes symbol grounding. So it's a prerequisite for symbol grounding. So what symbol emergence? It tries to answer the question as to how it's possible for a computer program to use symbols which are not arbitrarily interpretable. Or, let's say, we need to allow agents to arrive at a common vocabulary to communicate, not necessarily intelligible. So, in neurosymbolic system, the symbols are the object wandering at both places. Let's say that Juan in this work, it talks how this process should be somehow, it's a very complex process, involves social intelligence, different kinds of intelligence, interaction with the environment, and let's say not binding into meaning that we bias them. So it requires a shared world model or theory of mind. You can see about world models, foundations, capabilities, laws, and benchmarks in this paper. Very new. And you can see how at the end reinforcement learning and actual learning is necessary for these behaviors to emerge and let's say symbols, because symbols are not just concept, a static concept. We need also actions in a dynamic world, right? So here you can see different predictors, simulators, evolvers, where all this can be put into place. Okay, this book also talks about this from the robotics perspective, but we need to start finishing. So one problem that I find, we have been working recently with Carmen, it's tackling a bit of both, continual AI and explainability. How? So what if we teach the foundational model, few examples of a new kind of problem? We got exclusive data, exclusive X-rays, and we want to teach the model about it. We know it's very clever, so few examples should be enough, right? So we use in context learning, because we just show a few examples and does not require fine-tuning. However, this paper of Benjo shows that this kind of asking them to elucidate, like chain of thought, is not explainability. Why? Because it actually shows that mechanistic computation may not follow the actual chain of thought steps. So what they propose is this kind of roadmap to ensure chain of thought causability, error monitoring, and correcting narratives. So these are some ways to fix it, but we take, let's say, a different approach. We ask the model, because we cannot know how much it knows from before and how much knowledge it's using from before, it's difficult to assess. So what do? We give some examples.
It's a question.
Yeah.
You are discussing about context learning, but really you are discussing the explainability to extract the concept from image.
Images,
but
yeah.
Image that they have an evolution along the time. But you are processing now with LLMs the question. You are processing now the image from LLMs, I understand, and you extract the concepts from the image. We have a continual learning because I understand that we have an evolution of the image, a video probably. Then I understand that with a methodology in the topic and with few shots, you are sending, or the model will send a new image to the large language model to extract the evolution of the concept.
Yes.
I understand correctly?
Yes, we don't use videos yet, but we show the LLM. This is a climate, a yellow iris. We only show maximum 5 images in each prompt. We upload them. This is a clematis and yellow iris. What class is this? So we assume that we are adding new knowledge. Of course, it's difficult to prove that it's new knowledge, but we tried with some data sets, and then we say, extract, this is one type of explanation. We ask 5 types of explanation. One is which features you use to classify this new image. So I want to know what concepts are important for LLM to say that this is violet or whatever. Extract only the smallest sufficient set of critical, concrete, observable visual features needed to support the classification. And we give instructions how to format. And it says, it's a clematis. Why? Because it has 5 petals, purple petals, and light color center with multiple stamens. And then we contribute 9 metrics that tell us how good this explanation is.
Well, now I understand. You have new image in the future. It's not a video, but you have new image in the same context, but with quite different information, and you need the connection with neurosymbolic or with the concepts, graph theory concepts, and try to have a neurosymbolic approach to conserve or to have the more important information in order to maintain the information about that.
So far we are just asking the model to see how it thinks. We don't have a neurosymbolic approach here yet, but that's next
you
steps.
Only have now, yes, you introduce the image and you extract with the prompt engineering, you extract the future associated to the image. And you try to get information for the new image according to the previous information in the same context.
In the same context, in the same prompt, yes.
The same prompt, now with future, without the neurosymbolic.
Yeah, next will be with
next
neurosymbolic.
Next step will be to include the neurosymbolic in order to connect.
Yeah, maybe next we can add a knowledge graph to say this is how the taxonomy of flowers works, or this is what makes different flower from another. So far we want to know in what state the models are, how good they are without giving additional information. That's why it's few contexts. And we define different metrics like textual groundedness, hallucination-free, concept counting, comprehensibility, conciseness, specificity. We define all this and see that actually we ask a LLM as a judge to correct or evaluate the first LLM. And what we find is that explaining is genuinely harder than predicting alone. So when we ask them only to classify without explaining, the model is much better. But when we ask them to reason and explain why is this and to formulate the rules, it's not as easy. So we conclude that these models may not be optimized to explain or predicting. So it would be nice if they could be for both, but They lack some specific instruction tuning required for formal machine verifiable explainability. So we just submitted this, but we are working on it. There is also another white paper on the opportunities of neurosymbolic AI in medicine. In this repository you can find it. There is some architectures, and we show for many cases in medicine the knowledge component, the neurosymbolic learning component, and the lessons learned. In most of them, knowledge graphs are having an important role. I let you hear some virtual doctors and genomics, for instance, cases. You can read more if you like. There is also many advantages of and approaches to use ontology engineering tools and LLMs as ontology engineering tools, because building the graph normally is tedious. You don't want to do it by hand, but the LLM can help you a lot, right? We can see also in context learning here enables multimodal LLMs to classify cancer pathology. The problem is that because it's normally a nearest neighbor approach, you may not always actually have the closest example doesn't mean it's always the answer, right? So what if you have a nearest neighbor that is from another class? So we need to explain this. What if the organ does not fit in a sample? So graphs here are also useful because they connect the same different concepts in the same. If the image is too large to fit it at once, we need to know that they belong to the same organ. In this case, the same concept, right? And lastly, I want to talk a bit of this paper we are presenting on Sunday at 8 a.m. in the Congress on low-cost concept-based localized explanation with Darian, my PhD student from Cuba. He's here somewhere, I think. So we show that all the visual language models align images and text, but for instance, grounding Dino detects new categories based on a text prompt. But you need to tell what to look for. What if we don't know what we're looking for? We just want to know new concepts or weird concepts that may be biasing. For instance, some segments without naming, but it doesn't tell you the naming or what is, it doesn't understand what is segmenting, right? So you always need to know the concept that you want to segment and to localize. And the problem is that we not always know the concept we are searching for if we want to debug or audit the model. So we propose a closed concept naming pipeline in which we ask LLMs to help us naming the segmented concepts. If the list of concepts is too large, because the concept normally gets short, we may find it thanks to similarity, cosine similarity, or asking the models. And we find that for class level this works fine, but for part levels it's not so much. Anyway, I will stop here because I leave here some. You can search more in the slides. I will share there in the folder, by the way, new models that should help us building this more actionable foundational models. I leave you some references of this in which you can get ideas on these topics of research. I thank my co-authors and the DAX Tool workshop seminar, my PhD students, international ones visiting and not visiting. And if you like these topics, consider applying to this European project that we just got. But now it got delayed to September because things are slow in the European Union. So it will start in September, so consider applying. Thank you very much.
Please, question? Yes. Here, for you. You first, and later, yes, you start. Come here and you use the microphone the second round, please. But please go up, and because people need to listen to you, elevate the volume, please. No. This is for the camera. You need your voice, basically.
Oh, okay.
Because in other case, people don't listen to you in the room.
Thank you for the talk. And I just wanted to make sure if I understood this correctly, if they're...
Stand up.
Oh,
Yes, but you need to elevate the voice because in other case, people in the room don't listen to you.
okay. Is it better now?
You must elevate the voice.
Okay. I just wanted to make sure if I understood it correctly, if you can use knowledge graphs as a way to verify the output of a large language model. So if it, let's say if it says someone has diabetes because of XYZ reasons, then you try to trace back in a knowledge graph. And if I understood it correctly, if you can also train language models with knowledge graphs, so that causal knowledge is sort of embedded in the weights?
That's right.
Okay.
There are many ways in which you can add salt.
Okay. Nice.
Yes.
And is there a way then, once the model gives an answer, is there a way that you can trace back to that training piece of data, which maybe was a node, an edge, some...
I think you could if you have access to the training data. The problem is that we normally don't have it, but maybe in context learning, if we isolate well what we give the model from what the model already has before, which is, I think, the hardest, we could, right? But that's the idea. I mean, I'm very interested in this line because I think we need to verify this, where the explanation fails and where the reasoning steps breaks. And if the model doesn't know step by step, like a logic reasoner, I like to think on ontology reasoners because they simplify, and with abstract reasoning you can see if this is valid. You could verify on the back. But of course, making something scalable with both sides is it's hot topic, and there are many things going on, but it's an active line of work. We will be working on this on the project. So.
Because I imagine if you use a knowledge graph to then verify the information given by a large language model, I was thinking that maybe you're verifying the factuality, but not actually finding the reasoning inside the...
Yeah, that's why we need both, right?
Yeah.
Some kind of, they can act as ground truth, synthesizing knowledge and multimodal aligned model, let's say information, knowledge, but the reasoning is also important. And most of models break at some of those things. They don't do everything.
Yeah.
So it's difficult. A lot of things to do.
Yeah. Well, thank you.
Thank you.
I'm not sure.
Well, first of all, thank you very much for the talk. It was very interesting as usual, Natalia. I want to first ask in the page 33, if you could go back there.
Okay.
Yeah. No, 33, no, sorry. 17, sorry. That was a question.
17 or 70?
17.
Okay.
Sorry. Yeah, there. So basically, if I didn't understand wrong, Monumai, it's like a classification model for monuments, right? But
it's a data set, Monumai, and an app also.
Okay. But the question is, if you have a classifier for images and you want to relate it somehow with a knowledge graph, how would you proceed? Because if I don't remember wrong, in the next page you have like everything for the classifier and the object detection. Like, how does it really work? You have an object detection algorithm and then you classify, or?
Yes, so you have, in this methodology, we call it XNASIR, you have two main components. The neural is NESI, no? Because the neural processing is some deep neural network, can be the detector of parts of arc, Muslim arc, for instance, no? All the parts are detected, and then you have a classifier. So both of them can be the black box, the deep components, right? But it's compositional. First you do the parts, detect it, and then you classify based on the detected parts. You have a loss, neural loss function, and then the symbolic processing, the C of NESI, is the knowledge graph in this case, that you have the explanation from the art historian. Let's say it's the ground truth. In this case, because it's quite simple, we only have 2 levels of hierarchies, the architectural style class and the, let's say, the styles, and then the architectural part. So if the explanation, you ask an explainable AI model, for instance, Sharp, explain me why you think this is Hispanic Muslim. You take this picture. You say, why is Hispanic Muslim? The model may say with Sharp, love arc, horseshoe arc, it's because of these things, right? So if we compare the graph explaining the model from the model with the graph explaining the model from the art historian. If there is an edge where it shouldn't be, or there is a node where it shouldn't be, we penalize the model. And this, we call it Sharp attribution graph. If the graph of one explanation and the other are not the same, each different graph, let's say edge or node, it's penalized, and this is the explainable AI informed training procedure. We call it Sharp backprop, because in this case we use Sharp, but you could use any other thing. Then we improve the model. So this results that the more explainable the model is, let's say the more aligned the 2 explanations are, the more performant the model is.
I have 2 follow-up questions. So first, comparing to a traditional GradCam method or line or something like that, is it way more costly?
Yeah, the part, it's not super efficient indeed, because you need to compute all the labels and all the detection, then classification. It would be ideal if you would do all at once, and for each, let's say you need to account if here the graph is small, but if it will be very big, maybe it wouldn't be so easy. So yeah, but the problem is with Sharp, you see the areas, hot areas, but you don't know if they are really the concept that they should be.
And also
yes.
Another question, sorry for
no problem.
So many questions. What happens when the taxonomy is not enough and you are out of distribution?
Yes, that's why we need the symbol emergence, and we need to say, hey, I have seen a new architectural component that maybe this one, where it has, instead of 3 or 6 little arcs, it has 8, and I never seen it. I don't know what it is, but it looks like Muslim because it has also red stripes, or it has some. So I wanted to explain it to me in terms of concepts, and this is why I think symbol emergence is important. But it's basically out of distribution or class discovery, but I want it to be expressed in terms of concepts that we already know. Okay. Even though we don't have a name for it. So we may ask an LLM to name it, and maybe we can, if we have the exclusive time of a doctor, which is very busy, we can say, okay, filter me things that are close to a tumor, or ignore metallic tokens like in UCI or peacemakers.
That's super
This is
cool.
kind of the idea where I want to go. Yeah.
Do you have more question?
No.
Okay, thanks. No, I have a question according your answer to Alfonso. It is very interesting. You say we have symbol emerging. Now I understand the importance of symbol emerging. But there are 2 possibilities. Symbol emerging because probably appear in different new images, but also we have the out of distribution and symbol that is out of distribution, and it may not be useful. Then you must design a methodology when you identify a symbol to include or not in the taxonomy, in the ontology. But I suppose you need to maintain an interaction with the expert. For example, this taxonomy was made by an expert in art, and you need to maintain a continuous interaction with the expert that are responsible of the taxonomy in a specific area. Is correct my interpretation?
Yeah. We want to minimize the interaction, but when we are not sure, of course, the human in the loop is always there, confirming every update to the final knowledge graph for sure. But if an LLM can help us decide, and an ontology could also help us decide, okay, this is just a new kind of Hispanic Muslim arc. It can have 6 or 8, but always an even number of arcs, no? So as long as the number of mini arcs are even, it's okay, for instance. So if an ontology can help us distinguish new specialization of really out of distribution things, but yeah, drawing the line and the threshold is difficult, I guess.
Yes, really, it is very interesting because really, but do you think that in the future, can you use LLM even to analyze the threshold of the potential new object before to interact with the expert? Because you need to reduce or minimize the interaction with the expert.
Exactly.
It has sense. Then really you need to be sure that the emergent object or emergent concept has a high threshold, or it is over the high threshold before to propose to the expert to check the new concept to be included in taxonomy. You need a loop with the expert improving the taxonomy, the ontology,
yes,
appear new object. This as consequence of the continual learning process, because you are receiving new information in the near future. The continual learning process is correct.
Yeah, that's where we want to go, and we want to use as much the foundational models to improve this. And that's why with Carmen we propose like 9 metrics for now. We left some metrics out, and I want to be. They were thinking it's too many metrics, but I said no. Every metric measures one thing, and because at the end the prompt engineering is the most important. So if we ask the LLM to have, for instance, local discriminativeness, we call it, because in a context you cannot see all the possible classes that the model is learning, and that's a problem because you only see in a prompt, right? So it's a bit of limiting, but as long as the rule doesn't separate one instance from one class, from one instance from another class, the explanation is not good. So I want explanations that are minimal, sufficient, necessary but not enough, necessary and sufficient to tell apart different classes. And by being very precise on this, we call it concept-based explanations, because there should still be nameable, and an LLM should still verbalize them, we will not be happy. And that's how we reduce this threshold, or we hope to do.
It is very interesting. Well, you have the question, but before, please, Nuria sent all you the teams, the groups. Please check if you prefer any change. Juan and Nuria can try, but it is so difficult because they try to have a balance according to the preferences, distribution people from Granada, Abu Dhabi and other places, and they try to have an equilibrium with the preferences of all people. 3 of you, I don't know if are here in the room, 3 people, I suppose they are not here, have not filled the application, and they include them in 3 groups with the 6 people, 5 with a clear election, and the last one that we don't know what will happen. But the idea is to, and they try to maintain your highest preference with this distribution. I hope all you be happy, but if you have any different preference, you can send to Nuria and Messi, and she can try to move. But it's so difficult because she needs to have the global equilibrium. Please check. Yes?
Thanks for the presentation. A lot of things to think about. Now, for the same slide, I was wondering, which is the difference between the classification performance with and without the additional step? Because in some way, if we add the sharp loss, we are forcing the DNN to think a little like us, but the DNN is designed to think differently from us.
Yes, it's very easy that you kind of depart, and when we force them to think and do two tasks at the same time, it was not easy to make it well, but at the end we managed to really surpass even a little bit. But it's not common. I must say that it's not always like that, because at the end there are biases that we are forcing the model, right? And as we see now with LLMs, when we ask only to classify, it does perfect. But when we ask to classify and explain why, it's not as perfect. So this is not a bit puzzling. So it's not always the case. So let's say it's just something we get stubborn to get, but sometimes it might be more precise. But I think it's still needed to pull the tongue to the LLM and say, what are you really looking at? If it's not able to verbalize, in my opinion, I don't trust the LLM yet.
Okay, thanks. And the second question is about the final part of the presentation. When you use the LLM to explain why a model took a decision. Okay. I tried some experiments about this, so I don't have a full, let's say, report. But I have a feeling. I would like you to elaborate on this, if you can. So my point is, when I ask the LLM to explain why the class was decided as class 1, the feeling is that the LLM is trying to say that I'm right. So it's like a lawyer, but is a defense lawyer. Okay. This is a feeling about some experiments, so I don't know if you find the same way.
That is very complacent, not to what you want to hear.
Yeah. So I'm saying this is Margherita, and he will tell me, yes, this is a Margherita because this, and this, but it's not highlighting the reasons why it's not a Margherita. This is my feeling.
Yes, true. Yeah, it's a very good point, the counterfactual explanation. We are aware of this, and this is why I don't use LLMs yet so much. Because I don't trust. I see that it's not. But that's where we want to go. And at the end, there is one metric we didn't use. All these metrics are local because they only look at the examples given in the prompt. But this is why the global is needed, right? At the end, we need all the rules to be consistent in all the examples in. But this is a conundrum because if in a prompt, in context learning, you can only show you are limited by your context window. Normally, you don't have a space to teach all the possible class. So in the next prompt, by definition, the memory is erased, right? Because it's in context learning. So I don't know how to do, because in a way you want to teach it with few examples and kind of works, but you want it to distinguish from other classes. So it's a very good question. I'm also disturbed by it, but I think with the correct metrics we can let it prefer ones versus others and make it discriminate. So those will be the next experiments. We can talk more offline. Thank you.
Another question here, please.
I was curious about the mechanistic interpretability slide. About the disambiguation of polysemanticity, what do you think that it's easier to do it on bigger models or on smaller models in terms of parameters, or there's no like correlation between the number of parameters of a model and the capacity to disambiguate the concepts?
I actually have a slide for you. Where was it? So there is some models that I think when they are smaller models in context learning. Okay, it's not maybe mechanistic. Mechanistic, I need to study further. But in terms of I don't know if that has an influence, honestly. But in context learning, they show that maybe I remove the larger the model is, kind of it gets more polluted. Like even if you give in context examples, no, we said if the model has too much knowledge, it's kind of biased or forcing to, like, it doesn't pay too much attention to your examples. So, and if it's smaller, there was something like that we found. It should be in the slides. I don't remember where, or maybe I removed. So, but yeah, large and small, it's a bit difficult to measure. But yeah, there are weird things, like if they're optimized for reasoning or not reasoning, there are many things to study. Yes, I don't remember if I put it. Anyway, yes, this needs to be studied. It's not well understood, like many things. Okay.
Well, any other comment? Any other question? Well, yes, perfect. We are in time today. We got at 1 o'clock the lunch. 10 to 1 is perfect. And in 5 minutes we can go directly to the lunch. After the lunch, we have a double talk, Patrick and myself. And later you have a meeting with, after our talk, we have the coffee break, and later a meeting with Nuria and Juan to receive the final instruction and to arrange the teams and the place for working. Well, in 5 minutes we can go to the Thank you very much, Natalia. Have you received my WhatsApp?
Yeah, thanks so much.
We have the ticket. All is okay. At 9:30 night, we must meet in the Alhambra, okay? I send you the place, the set place for the meeting. I will go. I have classes now. I must go to the school. I have 5:30. I have classes. I must go to my school, to my class with my students.
Sure.
I must go back at my house, pick
sure.
up my wife, and my wife will. 5 o'clock, I will be with the student at 5 o'clock. But you have 40 minutes more or less.
No problem.
And my idea is to complete. I have yesterday I present 2 parts in order to present an additional part today after you in the same session. Because you told me with 40 minutes more or less is enough, and then my idea is to use the remaining 40 minutes. In fact, in the school you can check that we have the 2 parts together. Well, good afternoon. We start the third section, the double session of this afternoon. Remember, after this session we have for the people is online. Okay, good afternoon. We start the third session. This is a double session. First, Patrick Cheridito from Polytechnic de Zurich will present the talk of efficient for regression, Wasserstein, Barycenters, and Normalizing flows. Patrick is a professor of mathematics in Polytechnic of Zurich. He's the director of the RIX Lab and FinsureTech Hub, and he's also member of the AI Centers and head the data science group of the Swiss Association of Actuaries. His research interests are in stochastic modeling, mathematical finance, quantitative risks, and insurance mathematics and machine learning. We have a double presentation in this session. Patrick will we use the half of the session approximately, was the idea. Feel you free. Fine. And the second part will be the third part of my presentation that yesterday, remember, I say that today I finish my presentation. We will have the coffee break, and after the coffee break, we have a session with Juan and Nuria that they provide you any explanation, any question about the team groups, the project student, and then we will distribute the 8 teams in the different places of the building for to start to work at 6:30 approximately. Then you can start the things and to start to discuss and to discuss and to think about the project that you have together. And as you can check in the program, we have different in the afternoon. Usually we have different slots for working together in order to discuss and continue the collaboration. Well, Patrick, please. Thank you very much.
Well, thanks so much for having me here. So this is on efficient fair regression, and interestingly, it's connected to Wasserstein Barycenters. So I will use elementary mathematics. So please ask if you have questions. Who knows the Wasserstein distance? And who knows what a Barycenter is? Most of you, I guess. So, okay, I try to explain these concepts and how it's related to fair regression. So this froze right now.
Unplug.
Yeah,
It worked for me.
I mean, there should be a computer scientist somewhere in the room.
Yeah, I'm not. Okay. Perfect. So this is about the insurers. So they use an increasing amount of data to price insurance policies. So somehow they become like the big tech companies who collect more and more data. So this leads to more precise estimates of individual risks. So as more data they have about you, the more precise their estimates are what kind of risk you pose to them. Okay. On the other hand, this goes against the idea of solidarity in insurance. So some countries have prohibited use of certain characteristics. So for example, in the EU, it's prohibited for insurance companies to use the fact whether you're a man or a woman. Okay, so they have to treat you equally. Some countries prohibit the use of age, ethnicity, religion, whether you're married or not, credit score, zip code, so this is where you live, employment status, education level, and insurance pricing. Okay. On the other hand, machine learning models are trained to minimize prediction errors. And if you do that, you can implicitly encode and amplify existing biases with respect to sensitive attributes as gender, ethnicity, and religion. Okay. So, for example, in insurance pricing, the risk prediction might be correlated with some predicted protected characteristics. In credit scoring, predicted default probabilities might systematically differ across demographic groups. In hiring, the predicted performance scores could exhibit discriminatory effects. So the goal of this talk is to formalize demographic parity, which is one concept of fairness in regression. There are others, but demographic parity is one of those that is widely used in a regression setting. Okay? And so we want to show that the optimal fair predictor is characterized via optimal transport theory. Okay, so there is an interesting connection between a fair regression and what is called optimal transport theory, which has been widely studied recently in different areas of mathematics and also in machine learning. So the key mathematical concept here is the concept of a Wasserstein Barycenter. Okay, so a Wasserstein is a distance between probability distribution, and the Barycenter is the weighted mean between different distributions. Okay, and then if I have time in the end, I will also say a few words about the efficient numerical methods for computing Wasserstein Barycenters. So in the first part, I tried to explain the concept, and then in the second part, I also tried to say a few words how it can be computed efficiently. Okay, so let's say we have a data generating model. And so here I have a random vector, x, s, y, on some underlying probability space omega. And x is features, d, okay? And so these are non-sensitive, these are open, so you're free to use them, okay? So this could be age in car insurance, or the type of your car, or your driving experience, these kind of, so these are open, right? And then I have sensitive features. Okay, so this could be gender, ethnicity, or religion. And I'm kind of not allowed to use those to discriminate against you. Okay, and then I have a target variable that I try to predict. Okay, so this could be the costs if you bought an insurance policy from me. So that would be the costs that you're going to cause in a year, for example, because you have a car insurance, or it could be a credit risk or something like this. Good. It could also be multidimensional. So for example, in insurance, one often tries to predict frequency of events and the average cost of an event. Okay, and those two could also be correlated. Okay, but for the moment we're thinking of the target variable y just as one-dimensional, say a cost that you're going to cause if I'm selling you an insurance company. Okay. Then what is standard regression? So standard regression just seeks a predictor, which is a function, which depends on all these variables, the open ones and the protected ones, which minimizes the mean squared error. Okay, so this is the expected squared difference from my prediction from the actual target. Okay, so I guess you have seen this before. So this is standard regression. So the best unconstrained predictor here would be F pure. Okay, and we know if we try to minimize the mean squared error, the best predictor is the conditional expectation, okay, of my target variable, given the open variables and the protected variables. Okay, so for everybody is familiar with the concept, I guess, right? Very good. So another question for us is, how do we constrain F, this predictor, so that it does not discriminate protected groups? Okay. But I still want to stay as close to the best prediction, F pure, as possible. Okay, and so here we're going to use this concept of demographic parity. Demographic parity means the following. So I have a predictor F that is using both variables, the open ones and the protected ones. Okay, but what I want is that the conditional distribution of my predictor, so that would be the left side here, given that the protected variable is in one state, for example, given that you're male, should be the same as the conditional distribution of my predictor, given that you're female. Okay, and this should hold if I have several categories of protected variables. It should hold like the distribution of your predictor should be the same, conditioned on all possible values that the protected variable takes. Okay, is this concept clear? Yes. Very good. So the distribution of the prediction has to be independent of the sensitive feature. So the interpretation is for each group S, we denote the conditional distribution by mu S. Okay, this is the conditional distribution of the predictor given that I'm in a particular group, say male or female. Okay. And then I require that all these conditional distributions are equal. Okay? And so this is not an easy constraint. Okay, you're trying to solve an optimization problem now, a best prediction problem, but under this constraint. And that's not an easy constraint. It's a distributional constraint and is much richer than saying the conditional expectation is the same, for example. So this is also a concept. It's called mean parity. Okay, so what's our problem now? So the fair regression problem now is I still try to minimize the mean squared error. So I try to find a predictor that is as close to the target as possible in this mean squared sense. But F has to be fair. Okay, so F has to satisfy this constraint here. Good. So this concept of demographic parity is also known as statistical parity or group fairness, and there is literature about this. Okay, so the concept is clear. Yeah. Very good. So, but now you might ask you, okay, why don't I just solve this regression problem by ignoring the protected variable? Why wouldn't you do that?
There might be correlated.
Exactly. Exactly. So one naive idea would be, okay, I'm not allowed to use the protected variable, whether you're male or female, for example, or what your ethnicity is or where you live, right? I just use the other variables for regression. So I calculate this, the g of x is just conditional expectation regressed on the allowed or the open variables x. Okay, problem is this does not guarantee demographic parity in general. Why? Because X is typically correlated with the protected features, okay? And so if you do that, then this regression will not satisfy the demographic parity principle. So the conditional distributions will not be the same because X typically correlates with S. Okay, even though you didn't specifically use the protected variable S. This is called proxy discrimination. Okay, so as a consequence, if you want to achieve this concept of demographic parity, you have to actively modify the prediction distribution, not just dropping S from your prediction. Okay, so the key insight here is if we denote these conditional distributions by mu S, the problem reduces to finding a common target distribution that I call nu here. And for each group S, a map, TS, that pushes the conditional distribution that I get from my pure regression problem to this fair distribution nu at some minimal cost. And so this is exactly an optimal transport problem. Okay? What's optimal transport? So this was introduced by Gaspard Monge a long time ago, and Gaspard Monge was an interesting character. He was a minister during the French Revolution, a mathematician, and he was also a co-founder of the École Polytechnique in Paris. Okay, and his wife's family owned mines. Okay, so maybe this was one motivation why he started thinking about this problem here. So on the left side here you have different mines. Okay, and then on the right problem you have factories where people build something with the ore from the mines. And then the problem is how you're going to transport what you're mining here on the left side to the different factories. Okay, then in a mathematical formulation, Monge's problem is this thing here. You have X, which is one location over here. And then you transport it with some map T, okay, over here, okay? And then you integrate this whole thing over the original distribution mu dx, okay? And you want to do it in such a way that you transport the distribution mu to your target distribution nu. Okay, so in a picture it looks like this, okay? So you have some initial distribution over here. Think of it as a pile of sand, for example. And now you want to move every grain of sand over here. So every grain of sand x here is transported to T of x. Okay. In general, there is different ways of doing this. Okay. So you could move like the leftmost grain here to the rightmost part over here, or you could move the leftmost grain over here to the left part here. Okay. But typically what you're doing is you're introducing a cost function c, which depends on x and T of x. And you want to minimize the average cost, okay? So you calculate the cost and then you average over the initial distribution. And that's Monge's transport problem. Okay, then what's the Wasserstein distance? Say for the cost, you just take Euclidean distance. It's like how far Tx is from x. You square this. You integrate with respect to the initial distribution. You take the square root. And you call this W2 between mu and nu. Okay, so now the nice thing is, turns out this is a distance or even a metric between probability measures. Okay. So it's like a Euclidean metric between points in space. This is a metric between different probability distributions. And this has given rise to a lot of nice mathematics, especially in recent years. Okay, so in analysis, in economics, but recently also in machine learning. Okay, now what can we do if we have a metric? We can calculate Barycenters. Okay, say I have different distributions, pi 1 to pi k, and then I can define the pi-weighted 2 Wasserstein Barycenter as the distribution that minimizes this sum here. Okay, so in a sense it's the distribution nu that sits in the middle of all these distributions, pi 1, pi 2, pi k. So in particular, if you say all these initial measures are point measures on points x1 to xk for some points in Rn, then this notion of Wasserstein Barycenter just becomes the usual Barycenter, which is just a weighted average of these points in Rn. Okay? Once you have this notion, you can also calculate averages of distributions like this here. So here I have 4 extreme distributions on the corners here. I can calculate different averages of these distributions in the Wasserstein sense. Okay? So you've also seen these pictures where one phase morphs into another phase. And so this is done with these Wasserstein averages. Okay? So here I can compute averages between those, between those, between those. And I can also compute Wasserstein averages between all 4. Good. So how is it connected now? So going back to our fair regression problem, by Pythagoras, I can decompose the mean squared error from my target variable to my best fair prediction into an irreducible error, which is the distance from the target to the pure prediction, plus the distance from the pure to the fair prediction. Okay? So if I want to calculate or use a fair prediction, I'm losing accuracy. Okay? And what I'm losing here is this excess risk due to fairness. Okay, so I'm losing a bit of prediction power. But on the other hand, I'm fair. Okay, so this is because the pure regression is just the L2 projection on all measurable functions that depend on x and s. Okay, now I want to reformulate my problem. So I can write the fair predictor as an L2 minimizing function. Okay, from f pure. So instead of approximating the target variable y, I'm now approximating the pure prediction. Okay. So now you ask, oh, why is this a complicated problem? I can just like calculate another projection or something, but you cannot, because the set of fair predictors is not convex. Okay, so you cannot compute this as a projection or like a typical projection problem. So a standard Hilbert projection theory does not apply here. Okay, but what I can do is I can decompose this mean squared error over the protected groups. So I can write this mean squared error as a sum over all protected groups. I write the probability that I'm in protected group S here. I sum this over all protected groups. Okay. And then what I see is I'm searching for like a probability distribution that is minimizing this sum, where mu s are just the conditional distributions of my pure regression. And so what we're looking for is the pi-weighted 2 Wasserstein Barycenter of the conditional distributions of my pure predictor. Okay, so that's the relation between fair regression and this concept of Wasserstein Barycenters. It's clear to everybody? Or? Yeah?
Is that expression like a...
So now I didn't hear you.
Is that expression a proper square root? Do you have any guarantee of finding that new?
Yeah, okay. So that's a good question. I mean, I'm making here implicitly a couple of assumptions that everything is nice and then this thing exists and is unique.
Okay.
Okay? But there is also boundary cases where that's not the case. If you have like discrete distributions and they're not so nice, but I don't want to go there, right? Okay. But in our setting, so this problem has a unique solution. Okay. So, and what I should have said, we're not only looking for the barycenter of these distributions, but once we have the barycenter, which is the fair distribution, we also need transport maps that transport from mu s to the fair distribution for every s. Okay. So now let's see how we can calculate this. Okay, and first I do a 1D target space. So for example, you only try to predict the cost. So Y is one-dimensional. Your feature space might be high-dimensional, but your target is just one-dimensional. Okay, and so here I'm writing, so let's assume mu and nu here are atomless probability measures, so they have no point masses, so they're like nicely, continuously distributed. Then the optimal transport map from mu to nu is this thing here, okay? So, and this is kind of, I mean, you can prove this, but this is kind of obvious. So you take the cumulative distribution function of your two one-dimensional distributions, f mu and f nu, okay? Then you invert the first one, and you apply it to your first distribution, okay? What happens? You get the uniform distribution, okay? Then once you have this uniform, you apply the cumulative distribution function of your first distribution to the first distribution, gives you a uniform. Then you apply the inverse of the second cumulative distribution function, and this transforms into the second distribution, okay? And this transformation is also monotone, because both these transformations are monotone. And if you have not seen this before, it looks maybe strange to you, but this is intuitive, because what it means is if you transport one one-dimensional distribution to another one, you move the most left point from the first distribution to the most left point of the second distribution, and so on. You don't mix, right? Good. What you can also show is this expression for the square of the two Wasserstein distribution. It's just the integral over the two quantile functions of the two distributions. The inverses of the cumulative distribution functions are the so-called quantile functions. So what you do is you write these two quantile functions, you integrate from 0 to 1, and that's an explicit expression for your two Wasserstein distance between the two distributions. Okay? So once you're there, what you can also show, and that's not too hard, is the Barycenter distribution is given by its quantile function. And what you do is you use all the quantile functions of your marginal distributions, and you take a weighted average of those. Okay, gives you another quantile distribution, and that's the quantile distribution of your Barycenter distribution. Okay, again, if that's new to you, looks maybe a bit weird, but it's natural to believe, at least, that this is true. Okay? So the Wasserstein-Barycenter averages quantile functions, not densities. So say your marginal distributions have densities, don't average the densities. Also, don't average the cumulative distribution functions. What you have to do is you have to compute the quantile functions. You have to average those. Okay? So then, what's the fair predictor if you have a one-dimensional target function? And that's going back to this paper here. It's you use your pure predictor. That's the best possible predictor. Okay. And then you check what value your protected variable takes. And then you transport from there using the transport function that transports the S marginal distribution into the fair distribution. Okay? So what you have to do is you don't ignore the protected features. Okay, you have to use them. And then you compute the best predictor, okay, which uses the open variables and the protected variables. Okay? Then you compute the conditional distributions of your best predictor given S is equal to all the little s, like given that you're male or given that you're female, for example. Then you compute the quantile function of your Barycenter distribution, and you use it to define this transport map that transport mu S to nu. Okay? So each group's predictions are optimally transported to a common target distribution, the Barycenter, which is the fairest compromise among all distributions. Okay? So again, if you want to go through this process of fair regression, don't ignore the protected variable compute the best prediction, and then transform it using these transport maps here. Okay, it's clear, or do you have questions?
For me, what's not clear is that not. Well, I will wait. What's not clear is when to apply this tool, because not always the data is unfair, and how do you distinguish when we have unfair data and we need to apply this fair regression method with all the disadvantages or disadvantage possibilities that it could have?
Yeah, it's basically given to you maybe by your own policy or by regulation. So again, in the EU, for example, if you work in an insurance company, you have to do this. You're not allowed to discriminate between men and women, for example. So if you're just going to use all your data and you run the best regression, typically you will discriminate between men and women, for example. Your prediction conditioned on being a man or conditioned being a woman, for example, will be different. And so implicitly, you will treat these two differently.
So the suggestion is in edge cases, is when policies tell you to do it, you will use it and that's it, even in edge cases. Okay, thank you.
Great. Any more questions? Okay, so this was basically the concept and how you can compute this if your target variable is one-dimensional. And the last part is how you can compute this if your target variable is multidimensional. Okay, so now I say my target variable is in Rn and n is 2 or higher. Okay, so how can I compute this fair regression problem here? And so what turns out that you have a nice formula here. So let's say you have a probability distribution pi over the protected groups, okay, that you're not allowed to discriminate against. And let's say you have probability distributions mu1 to mu k, which now are distributions on mu n. Okay, let's assume you have some. In the background, you have like an n-dimensional random vector with an easy distribution. Typically, that's an n-dimensional normal distribution that you're going to use. Okay, then what you can show is you can write the minimization problem, which is a bit complicated. But the important thing is you can write this as a minimization problem. Okay, so in the end, you can use some kind of a machine learning model, say a neural network or something, to try to approximately solve this minimization problem. Okay, and also the pi-weighted 2 Wasserstein barycenter will be given by the distribution of H, okay, where H is a weighted sum of these G functions that solve this minimization problem. So this is a generalization of the concept that I've shown you in 1 dimensions, where the barycenter was given by the quantile function, which was a weighted mean of the quantile functions of the marginal distribution. So here what I have to do, I have to solve this minimization problem. It will give me a function g which depends on x and s, and then I have to take a weighted average over the protected groups of this function g, and this will describe my barycenter. Yes?
Do you ensure that what you obtain is symmetric or not really?
Well, theoretically, this has to be a metric, but now I'm not interested in the metric anymore. So now I'm interested in this function h, okay? And I will also be interested in this function g, which will give me the transport maps that I'm going to show you in a second. But this is a computationally hard problem. I mean, especially if y is high dimensional, and especially if I have many groups here. So if k is large. So this is computationally hard now. Okay, and then Okay, what I will need is these transport maps here, which now are given to me by G and H, these two functions that I characterize here. I mean, this is a theoretical characterization. Now I'm asking myself, how can I compute these things? Yeah.
I have a small question. I guess in the decision problem, are we averaging over the dimensions by indexing over n? Or
No.
why we are like summing up to n?
No. So n is the dimension of the target space, right? So say I have a two-dimensional target variable now, right? So what I have to do is I have to average over the categories that I have, how many different protected subgroups I have. So there I do the averaging.
In the decision problem, like above in the part in item A, there is the summation, and also there is a subindex I over the G.
Yeah. Here?
Yeah.
Yeah.
Yeah. So we
okay. So here you have to compute this sum, and you have to try to minimize this. Okay. So you minimize these over all possible functions G, and I didn't explain this very carefully. So there are some constraints to the function G which you're optimizing over.
Okay.
But in the end, I mean, let me just try to continue here because I want to talk about one more thing. But in the end, this is a complicated minimization problem. The good thing is, and it has constraints, okay? The good thing is I can write this as a minimization problem, so I can just use a machine learning tool in a sense, right? So I parameterize all of this with a neural network, and I do gradient descent on this, and this works pretty well. Okay, once I have approximate solutions of G, I define H, and then theoretically I solved my fair regression problem in high dimension. Okay, so now I don't know how much, should I take another 5 minutes or so?
Yes.
Because I wanted to introduce another thing. So first I have a little illustration here. So first you do the unfair prediction, which is the best prediction, okay? So you don't care, you're unfair, okay? Then you calculate the conditional distributions of your predictor over group 1, 2, down to k. And then you calculate your Barycenter, and then you have to transport all your marginal distribution to the Barycenter. Okay? Then you also have this thing here, the price of fairness, okay? This is how much accuracy you lose by being fair compared to using the best predictor. Okay? I mean, if your best predictor already is close to fair, then it's not a big problem, right? But if your best predictor is very unfair, so it treats different protected groups very differently, then you have to correct the loss. You have to correct the distributions, and you also pay a higher price of fairness. Okay, and that's just this expression here. Okay, and so now maybe in the last 5 minutes I wanted to talk about normalizing flows. Okay, what are normalizing flows? Anybody?
They are invertible transformation of a distribution function.
Very good. So it's a generative AI model, okay? So there is different generative AI models, simpler ones, more complicated ones. Maybe the most popular at the moment are the transformers because they're used in the LLMs. But normalizing flows also have some good properties, and we're using them here. And so in the last 5 minutes, I'm just trying to explain how we use normalizing flows to solve this problem numerically. Okay, so that's a deep generative modeling via invertible maps. Okay, so the goal is to model some distribution on Rn so that it fits a given data set. Say you have like data points in Rn, okay, and now you want to construct a distribution that fits these data points. Okay, and so one way of doing is you start with like an easy distribution. So in most cases you start with an n-dimensional standard normal distribution that I'm denoting by p set here. And then you transform it. And normalizing, the idea of normalizing flows is you use a sequence of rather simple transformations. Okay, so this will help you also to invert these, but you use a lot of them to have expressive power. Okay, and the idea is to start with a simple standard distribution, apply a sequence of transformations such that your final distribution here is the distribution that fits your data. Okay? And you want to do this with invertible maps because you need to go forward and you will also need to go backwards. Okay? And so from analysis 1, you know that the one-step density transformations, if you do transformations like this, is given by the determinant of your Jacobian. Okay, so this is just how, if you transform, you have to adjust your measure because you're going to extend space or you're going to squeeze the space. Okay, so this differential here is the Jacobian matrix of your transformation. And then also, don't look at this too carefully, but you have an expression for the likelihood. Okay, and so what you're doing is you're training these transformations here, up here, so that you're going to maximize the likelihood of your data. Okay. How do you model these one-step transformations? With affine coupling layers. So the idea is you split your input data into two parts, A and B. Then you pass one part, you just pass it through. Okay? And the other part, you transform with an affine transformation that depends on the first part. Okay? Why is this clever? Because the inverse transformation of this is as simple as the forward transformation. You just have to subtract and then multiply with the exponential of minus this thing here. The Jacobians become lower triangular, so the determinant will just be the product of the diagonal, which is written here. Okay. And the functions S and T that you're using here can now be arbitrary neural networks. Okay, so these can be very complicated, but the structure of the transformation is still simple. Okay, and so now what we do is we use these normalizing flows to solve the problem that I wrote before. And just to wrap up, there's a small numerical result here. So this is a communities and crime data set. That's a US data set on where there is a lot of data. There is like 127 features. And then there is how many crimes happened in a neighborhood and how many police officers worked in this neighborhood. Okay? And that's an open data set that is usually used in connection with these fair regression problems. So the target variables are percentage of officers assigned to drug units and total number of violent crimes per 100,000 people. The non-sensitive features are 127 socioeconomic characteristics. And as a sensitive feature, we take here the percentage of the population that is African American, which is between 0 and 1, but we discretize this into steps 0, 0.01, 0.02. So these are 100 different protected subgroups I have here. Okay, so computationally, this is a pretty hard problem. And so what I'm showing here is what happens if I run a standard regression. Okay, how is the outcome correlated to my protected variable? And so I'm calculating 3 different correlation coefficients. Pearson is like the standard correlation. Then is Bierman and Kendall. These are 2 different measures of correlation. And what I see here, if I run a standard regression, I have high correlation between my predictor and the protected variable. Okay? And then if I run my method here, I get these correlations here, which are almost 0. Okay? So this computation works. This is some of the references that I used, and if there are more questions, you can ask now, or you can also ask me later.
Is this compatible? Because as you mentioned, it's very computational. It needs a lot of power about computation. Yeah. So is it compatible to reduce the space into a latent space, change with the flow, the fairness, and then regenerate the data again, so it's easier to compute?
It's a good question, but I don't know.
Okay.
Yes?
I was having a question, but I think you already answered it. It was, what do you do when you have a continuous variable in the subset of S? So you have to discretize it, right? Or could you make a convolution instead, or?
We're working on this right now with a PhD student. Okay, because like the traditional fairness literature is typically is like you have finitely many categories, like men or women, or different religions, or different ethnicities. But we're working with a PhD student on this question, so we try to extend some of the formulas we have here. I think you just write an integral over instead of a sum, but then everything else we're working out right now. And then how you compute it, I don't know, whether you discretize, I mean you can always discretize, right? Or you use some other method, I don't know yet.
Okay, thank you.
Sure, yeah.
Following this discretization problem, will this framework also work if we are working in discrete settings and, for example, using total variation distance instead of Wasserstein?
I guess you could use total variation distance. You just lose the connection to the fair regression definition that I use here.
Okay.
I mean, the question is what happens with this whole framework if you use a different notion of fairness. As I said in the beginning, what I'm using here is demographic parity, which is one concept of fairness, but it's not the only concept of fairness.
Okay.
So what and on the other hand, I have a Wasserstein Barycenter here, so I'm using the Wasserstein distance. So these two relate to each other. So now you can change your concept of fairness over here. You can use your distance between probability measures over here, but then you don't have the same complete story that I have. You have to check how it connects, right?
Okay. I was curious about the generative model you mentioned. It seemed similar to diffusion models. I don't know if it's similar or I just...
Well, in a way it's similar, except diffusion models are continuous time, you then discretize it, but this is discrete from the beginning. And there is no diffusion, so it's just a sequence of deterministic transformations.
Okay. And also, I was curious if you have like more than one protected variable, how should you assess or implement this?
Well, this fits directly, right? Because say you have two, but both those are
you can combine
discrete.
them.
Then like 2 and 2, I have 4. So this.
Okay. Okay. Thanks.
We start the secret match.
toque en fuente.
Ah, ahora no. ¿Queda gente?
Era para ponerlo.
Well, now we go back to my talk that yesterday. Remember that I did present 3 modules. The first ones I was talking about responsible AI, trustworthy AI, and also the risks and the governance. In the second module, I was talking about trust in AI, and today I finished in half an hour discussing about the reasoning stack in generative and agentic AI, and the discussion of why trust is hard in this kind of problems, particularly after the conclusions of the final slide last day. Remember that I did introduce calibrated tracks with different features, characteristics among them, usefulness, the safe and reliable, explainable, fair, human-centered of decision making, and to manage the uncertainty and the risks. Now today I focus the attention in the reasoning stack that we start with the transformer. We construct at the second level, the level of the foundation models, and then this last layer are the agentic AI models. And I will pay attention especially to the explainability and governance, connecting with the previous modules when I was discussing about this element in the trustworthy AI and as the foundation for defining or to work toward the tracks in AI. Remember that I was discussing the risks in the first module, and finally I finished with the governance. In the second one, I was discussing the trust, and in this way now I connect with the current theory or the current developments in the agentic AI. We have 3 layers: the layer of transformers, when we have the representation; the layer 2 with the large language model, the generative AI, and with emergent reasoning; and the layer 3 with the agentic AI, when we have the characteristic are the action and the autonomy. And really is explainability and governance is a cross-cutting in all of them. We must remember that intelligence emerges from stacking capabilities, and in the different layers, particularly in the two last layers, it emerges the intelligence, the capability, and not from a single model, but even with an action along the time. Well, in the first layer, we have the self-attention. Yesterday we had a short introduction about them. And you must remember that with the transformer, we have the contextual representation, parallel processing, and sequential modeling. A transformer, as the unit, it has no explicit reasoning, and it has not symbolic structures. And really, the relevance is the weighting and how they encode the relationship among the information. The problem is the attention is quite different. It's not equal than explanation, and we have difficulties to audit the transformer, audit the theoretical foundation of the theoretical layer of foundation models. We have not a causal trust, and with this kind of representation, we have an opaque model. The second layer is the LLM, really when the reasoning appears. And we know that the LLMs really introduce different characteristics and different technology in order to increase the reasoning, the chain of thought reasoning, the reasoning in context and learning, 0 shot, 1 shot, few shot, also in continual learning this morning. Natalia was speaking about that. We have abstraction and generalization. Really, the reasoning is not entirely pre-programmed, but arises partially. Really, we know that, of course, we introduce a lot of information in the pre-training phase, but really after that appear reasoning and appear partially a new reasoning that was not directly inside of the information that we introduce. In context learning, in large language models, we have the ability that if we introduce a sequence of information, it is possible to model directly and to generate the next example. It is possible to analyze the context and to create new or provide us new information. LLMs are associated to the theory of the general purpose artificial intelligence. Is the topic of the project of Natalia as the last end to analyze the AI system that provide us different capabilities in different scenarios, and they can do different action. They are not model a system for one action, but they are a system for that can work with different kind of information and take a different kind of decision. Of course, large language model and multimodal foundation model are the clear example of GPIs, but there are other kind of technology associated to this kind of technology. Characteristic of GPIs is that the reasoning, they problem solving as fundamental characteristic. They have a task generalization, and the reasoning is like a behavior. In difference, in contrast with the classical and traditional AI, here we have another kind of reasoning, and of course there is a risk, because the risk is also general, because we have not real constraint like in the classical AI models. And we have the problem, and we have some limitation when we discuss about GPIs, general purpose artificial intelligence. We have some limitation when we are thinking from the trust point of view. The lack of grounding in the reality, it appears inconsistent reasoning sometimes. It depends of the information, and of course there is a context-dependent performance completely. Then it's fundamental to fix the context, and to work in the context. And as this morning Natalia was explaining, to work in the context and to consider continual learning is fundamental for this kind of models. And we must distinguish in the emergent reasoning that we have with this kind of model, is fundamental to distinguish between the simulation and the understanding. Because really, when we work with LLMs, we are simulating in some ways the understanding. But we receive the output information in natural language that we can understand. We understand the information that we receive with after prompts, but really the system don't understand. The system processes the information, and we receive a simulation and of our understanding. Is a reasoning like behavior, but different than a reasoning like a human reasoning. But we have really, when we are discussing about to trust in AI and to trust in this kind of models, we must not consider them like the human reasoning, because they process information, but it's another way of information processing. Really, LLMs generate plausible reasoning, provide us answer, but they are not, they cannot guarantee us the correct reasoning and the correct answer. In fact, if we have not the context, the reasoning in the context, and we don't provide the information in the context, and in different ways, one of the projects are, for example, the RAG, the team that you are working in RAG, for working with introducing information context. Really, we cannot guarantee the correct reasoning. And we have the problem that I introduced yesterday. Really, the reasoning with LLMs is very fragile because we have the potential inconsistency across the prompts. Even with our question, our prompts, we can introduce inconsistency, they are sensitive to the context, and of course, always the hallucination can appear in the reasoning process. This produces an additional problem because really we have the second layer, the LLMs, and we have a third layer that is the Agentic AI. And the Agentic AI really is a transition from the LLMs to manage or to consider agents. In this way, the Agentic AI introduce or appear when we are using the LLMs or any foundation model in the second layer, and we include the action and the autonomy, or we try to take action and to design agents with autonomy. In this scenario, we have the layer with the reasoning in the LLM, and we have the layer with the action in the Agentic AI. And the problems of explanation, explainability, and governance, of course, increase because really we are proposing an general purpose reasoning model that provoke the action with the agent. In this way, we have a loop when the core loop is thinking, to act, to observe, and to iterate. One characteristic of the agent is that really they are connected with the LLMs, and they iterate continuously with the prompting in order to get correct answer and to have the capability that we know now with Agentic AI. The decision making, the action, the task execution, and the autonomy. And these characteristics provoke that this kind of model moves from answers that we receive when we are connected or interacting with LLM modes. When we interact with LLM modes, we receive answer. Now, when we interact with an agent, we are receiving we are checking actions because this lax layer transform the answer of the LLM modes in action. And in this way, really, we have a new characteristic, and because we have the reasoning, the tool selection, the action execution, and the feedback integration. In fact, in your project that we develop and the proposal that you have choose, the idea we can receive a proposal with the agents in a dynamic environment when we have this kind of action, iteration, and the feedback integration for any future problems. Well, in this complete scenario, the risks can augment because really we can propagate or amplify the risks. If we have errors in the models, in the reasoning, we have a cascade of errors because the hallucination provokes wrong decision, the misalignment provokes a wrong goal, and the tool that we use, or the misuse of the tool connecting the agentics with LLMs can provoke wrong actions. Then really we can propagate, amplify the errors, and it's necessary to design new tools, new theory in order to introduce explainability. But the explainability is so complex because, of course, from the theoretical point of view, the explainability is very low when we are using transformer. The explainability for LLM is a post hoc explainability. We try to understand why we receive an answer, or we try to understand, in the case of this morning, the presentation of Natalia, we try to understand why the system provides us some concepts or appear emerging concepts, or the distinction this morning we were discussing between the emergent concepts in contrast with the auto-distribution information that is so complex, as is the topic that they are working now. Really, we have a challenge. The challenge is to introduce explanation, to introduce explainability, and the explainability is different than the through internal reasoning. We have an internal reasoning with LLMs, and then after receiving the answer to interact with our prompt, we need to try, or we try to understand why we receive an answer and to explain why we receive, or why we have an action. And this is more complex than in the classical one. In this way, we have a local explanation per decision, global explanation for the model behavior, and we need to consider the tool we use and the wrong action, and try to explain or predict the potential wrong actions. Then we have different kinds of explainability that we need to develop now in this new scenario. Of course, the governance is also very important because it's fundamental from the real application. In your case, you are working with a real application, or we try to propose a project with a real application. It's fundamental, the governance, to define the boundaries, to enforce the accountability, the responsibility of the system, and to monitor the behavior. For any real application, you propose any real application in your project, it's fundamental to know exactly what are the boundaries in order to check the correct behavior of the model, to guarantee the accountability, to enforce the accountability, and to have any way to monitor the behavior, to guarantee the performance from the point of view of the safety. In this way, we have a lot of challenge with the governance, because really we have autonomy, we have unpredictability and interaction with external systems. The characteristics in this case of the agents is they situate us in a completely new scenario, in an open world, and we have challenge as the real-time oversight. We have the challenge of the responsibility attribution. Yesterday, in the talk, we have a discussion about the intentionality, and really we need to and the responsibility is fundamental to know what is the responsibility attribution and the compliance in dynamic system. We need to guarantee the compliance. Well, we have a gap in the tracks in this kind of AI system. We have a gap in the tracks because we have the opacity associated to the transformer. Second, the probabilistic reasoning. We have a probabilistic mechanism to produce words and internal capability of reasoning that we need to explain. And we have finally the autonomous behavior of the agents. We need again another kind of explanation, and the explanation together the governance, because sometimes we cannot display the action, but we need to know exactly the limits, the boundary, and to the remaining aspect of the governance. Really, the capability increase, we have more power, but we have more risks, and fundamental from the trust in AI point of view, we have more need for trust in AI system. And then we have three fundamental challenges in this with the new layer of Agentic AI. We have three challenges, and we would like to know your opinion in your project about the challenge which you discuss with real problem. The challenge of understanding the explainability in the output of the LLM model and the action. The challenge of the governance and the control of the system, and the challenge of the safety and the protection. And really, we have together the governance, together the safety, because we needed to put together the governance and to monitor the system to guarantee the safety of the model. Really, the challenges are very important, and in this idea, let me to introduce shortly the two fundamental components that I was discussing yesterday, the governance and the explainability. I will introduce shortly a short discussion about governance. Second, later I discuss about the explainability in this scenario. Basically, I have a question. In the case of the governance, I have a question. In the case of explainability, I will show you our advance, but very shortly. The governance is fundamental to consider different aspects. Here, in this slide, I include 6 elements, 6 aspects to consider for the governance of this kind of application system. The policy and standards, the risk management for any kind of problems, and the risks of to manage the risks of the action of the system, the accountability, they clarify the responsibility to assign responsibility and enable redress for harm caused, monitoring, auditing, and it is associated to the safety, to monitor the system, the compliance and regulation, and the human oversight, and to consider what are the stakeholders that are in the interaction with the system. Remember, yesterday I was discussing in a health or medical scenario, quite different is the stakeholder is the doctor or the stakeholder is the patient, because the output that they are waiting is different. In this way, we need a global governance scenario where we must consider the function across the life cycle, and to consider that we need to discuss from the design, the develop, deployment, to operate and improve the system, and with different governance principles. Another important aspect, or another way to discuss about governance, was proposed and is fundamental by a document of the United Nations. I remember Alfonso's question yesterday about who must control or introduce the governance. 1 year ago was published a document by the AI advisory body for United Nations, and they introduced the governance as fundamental aspect in the use of AI system, and they introduced the governance with 4 vertical elements. It's fundamental to guarantee the governance in the data, the privacy, the diversity. Patrick was discussing about the diversity and the fairness in the decision. Is fundamental to consider the fairness and the diversity to avoid any kind of discrimination in the data. Second, the model is fundamental to audit the models and to audit all the infrastructures. The third aspect is the benchmark, the testing of the model to introduce red teaming and to guarantee a priori a correct behavior of the system. And the last one, fundamental aspect, is focused in the specific application area, because we have rules and we have different sectoral permission and different aspects, human rights and so on, that we need to respect. Then, according to the proposal of the governance of the document of United Nations that which was, we must also consider this element, and we must consider the governance is really and manage the AI cycle is at 360-degree, manage completely the AI life cycles. It's fundamental to consider the action, and in this way we must consider the concept of responsible AI system. The responsible system is a system that we consider the context, we consider the data and the operational design domain. We must design the AI model thinking about trustworthy AI characteristic. We need to audit and certificate the good behavior of the model, and we need the accountability, the inspection, and the governance along all the life cycle of the system. The governance is fundamental, and it's fundamental to consider the governance when we are discussing about the context, we are discussing about the model, the auditability, and of course the accountability and inspection. And we need really the governance is a layer inside of all the system. From a societal point of view, it's also to think and to consider the trade-off between the AI system and when we are working, while discussing from the societal point of view. For the societal point of view, for the users, people are thinking about the societal risks, they are thinking about the fundamental rights risks, the legal uncertainty, the fragmentation of the risk regulation is a problem, a current problem, and also the discussion about the use for social good and humanitarian work, the trade-off in the use of the potential usefulness of this kind of infrastructures that also introduce a discussion. And a stop point before to finish with the governance is a point or a requirement that was introduced by the European concept of trustworthy AI. Remember, I was discussing yesterday that when we check the requirements from Europe, the high-level group in Europe, and we check the requirements in the NICS from America, we have two aspects, two requirements that were different, particularly in the case of the European definition of trustworthy. We have the human agency and oversight. This is a fundamental aspect in the European regulation, that the system should complement and empower humans without replacing them. This is, from the theory, is very easy to say and to write. The question is the trade-off from the automation and the design of autonomous system and the replacement of different work. But it's a fundamental aspect. We are thinking about a high-risk scenario when the human must take the final decision. The last concept I want to introduce very shortly, because we are near to the end of the session, is the explainability. Explainability, in my opinion, is the fundamental requirement in the trustworthy AI design, because explainability is fundamental for safety, it can help us for safety, and also fundamental elements for the governance and the auditability and so on. And the explainability, we know that when we are working with this kind of a system, generative AI, foundation model, and agentic AI, usually we are discussing about post hoc explainability techniques, that we try to explain the results after to receive the answer of the system. When we are working with particular application, of course, we have different kind of explainable explanation, and we can find explanation for tabular, for image, for text, for time series, or for graphs. But in the particular case of the LLMs, we must pay attention to the different possibility to highlight some part of the sentence and the prompting, and to connect the prompting with the output of the system. And we must remember that never opacity is eliminated, particularly in this kind of a big model. We always have a reducible part of the opacity, and we have accidental opacity that we can reduce. We can introduce partially explainability, but there is some irreducible explainability that we need to manage. In this way, we need to manage the opacity with, and institutional trust delegated when we need to introduce the governance, the oversight and compatibility, and the possibility of the contestability. And we need to introduce to manage or to reduce the accidental opacity and to consider that we need to govern the irreducible responsibility. We need to reduce, improving all aspects associated to the model and the data, and with explainability, we can reduce the accidental opacity, and we need to monitor the irreducible opacity. Another important aspect when we are discussing about LLM and large language model is that in the classical theory, people are discussing about explainability from a static point of view. We have a model, we have an AI system, and we receive explanation about the action. In this case, it's fundamental to consider that we are in a dynamical scenario, and we need to consider that we have an interaction and interactivity with the model. And we need to introduce this interaction, and we introduce an explainability loop, when we have the explanation generation, human feedback, the belief on the explanation, the potential adjustment, and finally the opacity governance in the irreducible opacity. And then, in this way, in our recent work with some colleagues, Marco Lopez de Prado from Adialab, and other colleagues from Granada, Jaén and Oviedo, we introduced the co-explainer and framework in order to manage the potential harms with an iterative models that we introduce the explainability, the explanation, the feedback to update and to govern this kind of models, and considering the context from the point of view of the stakeholder, because we must always to think in the stakeholder that are using the model. Very quickly, I will not spend time because we are just on the time. Working with LLM is we must consider the following aspect. It's fundamental. The challenge is not to interpret what was said by LLMs, because when we receive an answer, of course, and we read the answer of the LLMs, usually we say it's good. Really, the answer is very good, always. Even in an hallucination, the answer or the figure is really excellent, because if we are not expert in the context, we can receive an hallucination, and the answer for us is well written, is coherent, and we can believe. Then really our objective is to understand why it was said. We need to understand why we receive this answer by LLM, because if we understand why, we can even to discuss with the model and to analyze really the diversity of the model. In this way, we need the explainability. We just published some days ago a model, a first proposal, a TASAL framework, is part of the PhD thesis of David Herrera. Here, but he will not work in the topic of explainability in the team. He chose another one. I propose him to choose another proposal of the project, and we propose an triadic model when we introduce the cognitive, the functional aspect, and the causal aspect of the answer in order to try to understand why the model received the answer. Very quickly, we have an iteration, identify a stakeholder, design, choosing the explanation, generating the explanation, evaluating them, and the deployment. You have the reference, then I will not take time, and you have here a figure for the complete model. These are the 4 references. I will provide to Marta the PDF files, and you can read them. These are 4 papers, and in this paper, the first one was in 20, the Natalia mentioned it, we worked together. Natalia were then in France, your address is France, it's Paris, in this paper. Later, she come here, and we were discussing, and we introduced the definition, explanation, explainability that I use it, and also Natalia, and recently I developed it with a colleague from Madrid, Regis Calderon, the tree of opacity and explainability, and we developed also co-explainer and TASAL methodology. I also recommend you 2 papers. It's a very good analysis overview, published in February this year, from Netherlands and Toronto, with the author that discusses the transparency in agentic AI, and also an interesting big paper, more than 100 pages, about the agentic reasoning from people from Illinois, Meta, Amazon, Goodyear, San Diego, and Yale University. And we are finishing a paper that we will provide you a copy. We are cooperating in a project that Isaac Triguero, my colleague from the Research Institute and future director of Research Institute, about the traps gap, and was associated to the second part. Well, we are in the concluding remarks. I start with a picture, dark picture, remember the dark picture of the Alhambra. This is the same picture, but the clear on the day. We have the sky, we got clearly the Díaz, but we are in the same situation. We need to reach out to decide how to trust in AI. And it is so difficult to trust in AI because we need to design all the governance elements in order to trust in an AI system. And the question is, are we ready to trust in a system we don't not fully understand them? Really, is a problem. And when we are working in AI, we have a different conception on trust than the society and the people that are thinking on the risks. And really, the risks are there. According to the reasoning stack, and from the representation transformer to the emerging reasoning of LLMs, the general capability of, from the point of view, general proposed artificial intelligence, and the autonomy and action of the agentic AI, really, if we think in artificial intelligence, 5 years ago, when we published, in 20, we published the paper about explainability, working with a static AI system, that we have data, and we receive and prediction. The situation is quite different. We are working with the same definition of explainability, is correct, but the scenario is quite different. We now need to introduce explainability, governance, and safety in a quite different scenario, with quite different models, with a general purpose, and with a continuous interaction with the people. Then, the question is that if in this scenario, we are discussing about responsibility with model with high capability of reasoning, and the question is, if are we ready to trust in a system? Really is the question, because it is really the fundamental question now for people, for society, in order to use and to trust really in the use of a system. Remember that we introduced the calibrated trust with the different factors, the technology factor, the context factor, and the human-based factor. It's fundamental to consider them to calibrate. But really, we must consider, to conclude, please think about these next 4 points, particularly in the last one. A system don't think like humans. We agree. When people try to compare humans with a system, it's an error. They are quite different. The humans and a machine are different. They don't think like humans, but they have emerging capabilities of reasoning. They simulate reasoning. If we are thinking of the human reasoning, but it's a different reasoning, but they have reasoning. They act with an increasing autonomy. Every week, every month, we have new AI system with an autonomy reasoning and really high capabilities. The last one, 1 month ago, Mythos, the foundation model from cloud that now we know that is from the security point of view is a fundamental tool in order to guarantee the security of any digital infrastructure, because Mythos is discovering a lot of risk problem, the terrorist problem, and really is incredible. And the question is, what do you think about if we are starting to live with another kind of intelligence? Why a lot of people, particularly in the artificial intelligence area, always say, no, they are not, the machine don't think. The machine don't reason. The machine has not intelligence. Okay, but under these sentences, what happened with Mythos? Was trained with a lot of code, a lot of information about security. Eventually, Mythos can discover problems that nobody as human can look for in an infrastructure. That in some way we have another kind of intelligence. This is the question. My personal position, I think that we have another kind of intelligence. It's not a human intelligence. We cannot compare continuously the intelligence of the human with an AI system. But if we consider a definition of intelligence, of processing information, take knowledge, and take action, is really we have a cognitive intelligence. We are far from a physical system, of course. We are far for a general AI or a strong AI. I don't know if we can get a strong AI. Probably, as all companies say, next decade we can reach the general AI. But probably we are in front of another kind of intelligence. And in this way, trust, we must think in the trust through evidence, no intuition. We need to test and we need to test we have the possibility to test the system. We need to use calibrated trust over blinded trust. We need to move to calibrated trust in order to know exactly how they really are running. It's fundamental to think in the governance that a governance enables trust at a scale. It is fundamental we trust in AI because it is governed, not because it is full transparent. Never we have full transparent AI system. They are more and more complex, and we have opacity. We need to govern them, because never we will get the complete transparency and explainability. Explainability enables us to understand where it matters, but we can understand partially the system. Really, therefore, is fundamental an aspect, the human oversight in the center. We need to consider the human oversight to keep the control, to take action, because the ultimate responsibility remains in the humans. It's fundamental. We do not trust AI because it thinks like us. Never we can compare the AI system with the human and think we trust in AI system because it has similar behavior than human. It's an error. We trust in AI because it is tested, it is governed. We can introduce explainability partially. It may be predictable. The problem is when we have emergent behavior that we cannot predict. It's a problem, and always it is under human control. In this way, we can trust in the system. We need to put together all these characteristics to trust through the evidence, calibrated tracks, governance and fundamental elements, explainability and the human oversight. In this way, we can trust in a system. And this is the current scenario. Really, if we think that we can remember the image at the beginning in the door of our center. We need to go up to the Alhambra mountain. This night we will go to the Alhambra. In a fiction scenario, we can reach the Alhambra, we can say we trust in AI, but today we cannot say we trust in AI. It is really a long journey, because in order to be ready to trust in AI, we need to design more and new explainability capabilities, explainability methods, and we need to design governance methodology, including safety, human oversight, and all aspects of trustworthy AI to trust in any AI system. We need to define perfectly the box when we have the governance and the AI system inside of the governance box for this AI system. In this scenario, we can trust in the AI system, but we are now very far to have this scenario. We have a long journey to get this scenario, and probably now, in this decade, we will observe new and new advances in AI, more and more emergent capabilities, and we need to work in parallel to design the explainability, the safety, the monitoring AI, using also AI system, and to design the complete governance scenario. Thank you very much, and we have now half an hour of coffee, and later we have the meeting with Nuria and Juan. We have no time for questions because we must drink the coffee, but if my talk was a provocative talk, because I am discussing if we are in front or not of intelligent system. We have time to discuss this week.